the mic. For anyone on the live stream, we'll be kicking off in about 10 minutes at 4 a.m. GMT or 2 p.m. Melbourne time. Hi everyone. We'll be kicking off at about 2 p.m. Melbourne time, so in about 5 minutes. Just be patient and we'll be underway. Hi everyone. So right on time at 2 p.m. Here in Melbourne. We're gonna try and kick things off in about a minute or so. But in the meantime, I can introduce myself and give you a quick rundown of how things will work today. So my name's Gwil. I'm one of the co-founders and the creative director of Fologram. tech startup that is building software for mixed reality devices. And I'll be running the workshop this week with Sean Guy, who is the Fologram for Rhino product manager and general expert with all things digital fabrication. We're using YouTube Live as the platform because we had quite a few participants in the workshop that wanted to follow along with the tutorials, and we'll be saving these and publishing them after doing the stream each day. But we may also use the Fologram community forum quite a bit to communicate with you all asynchronously, so outside of these live streams and tutorials. And if we need to, we might use Zoom and Google Hangouts and things like that as well. So the way things will work for today is I'll be giving you a kind of an overview of some of the work that we've been doing at Fologram recently and introduce you to a couple of themes or approaches that we'll be exploring within this workshop, specifically looking at how we can use augmented reality or mixed reality to assist with complex fabrication tasks. Now, given that this is a remote workshop, I'm talking to you most likely from the other side of the world. It looks like we have a couple of people from South America in the chat. We won't be necessarily doing any physical making in the workshop, but the intention is to provide you with a kind of a contextual understanding of what is possible, as well as the technical know-how to go and deliver projects on your own, maybe in a design studio within your practice or some other kind of creative project that you might be working on at some point in the future. Throughout the week, we'll be very much active on the forum. So the idea is that we'll be running these tutorials over YouTube Live to introduce you to some key technical concepts, and then in your own time you'll be kind of putting those skills into practice, and you'll be able to keep in touch with us and with others in the workshop over the forum. At the end of the workshop, we'll be using a platform that we've been developing at Fologram called @Studio to publish and exhibit a few of the projects that you produce. That's going to be a big experiment. We're not entirely sure how that's going to work or what that's going to look like yet, but hopefully there'll be some kind of outcome that you can share with others to demonstrate what you learned and what you did in this workshop this week as part of Digital Futures. Okay, so next 45 minutes or so, 45 minutes to an hour, I'll show you a couple of projects. Projects will be exploring particular themes that we'll be introducing to you all over the course of the workshop, and I guess ideally it'll kind of get you excited about what's possible working with Fologram and mixed reality. So from reading some of your portfolios and applications that you made when you were choosing to join the workshop, many of you have some experience with AR and VR already. I'm sure many of you have also seen some of the projects that we've done at Fologram, and so the intention of this presentation is to try to go behind the scenes to some extent and to discuss some of the more technical concepts and ideas that made some of our work possible, as well as introducing you very, very briefly to a little bit of the kind of the background thinking and ideas. So the first thing to make clear, I think, is that AR and VR are two entirely different technologies with entirely different use cases, even though they tend to be lumped into the same acronym. You know, AR/VR, I'm working in AR/VR is something you hear all the time. And it happened with these Digital Futures workshops as well. You may have noticed that AR and VR have been lumped together into one category. But augmented reality, as it was initially conceived of as a technology by two engineers at Boeing, who they kind of invented the term augmented reality, has always been intended to be used to assist with making things. It's a technology that in its original conception was intended to help workers understand spatial information. So things that could be very, very complex to interpret from two-dimensional drawings, like wiring diagrams or the location of, in this, as in shown in this kind of this sketch, where drill holes need to be located in an aircraft wing. Augmented reality really is a technology that assists somebody in doing some physical task by extending their skills at locating spatial information. That's what it's for. More recently, augmented reality has become more associated with things like Pokemon Go, Snapchat filters, things like that. That is a departure from the sort of original conception of how this technology might be used. And it's something that we at Fologram have always tried to keep at the sort of front of our minds. Like, how can we use AR to assist with complex fabrication tasks? So it's not a new idea, what we're doing at Fologram. It's the first idea, and we think that it's quite a good one. Now, the engineers at Boeing back in the 90s, when they described their AR system for helping with building aircraft, there weren't readily available augmented reality headsets available on the market. They had to build their own one. It was a kind of a hackathon type project where they jerry-rigged a bunch of off-the-shelf technologies together to put, to produce something which would assist workers with their fabrication tasks. But it was a custom one-off system. It was extremely expensive. It required a lot of training to use, and it tended to make workers sick, and it wasn't particularly accurate. So what's happened in the sort of 30 years since is that consumer AR devices have just gotten really, really good. And since sort of 2015, 2016, when the HoloLens 1 first came onto the market, they've gotten relatively cheap and very precise. So what we work with at Fologram up until recently was the HoloLens 1, now with the HoloLens 2. It's a self-contained computer, so it's basically like a phone, I guess, that you wear on your head, and it has state-of-the-art inside-out tracking. So it's able to work out where it is in space by tracking features in your surrounding environment and position holograms accordingly such that they appear not to move. Now, over the scale of, let's say, a typical workshop environment, maybe up to about 10 meters, if you're fully aware of following best practice for calibrating these devices and setting up a physical environment that is well suited to tracking, you can achieve pretty good precision with the HoloLens straight out of the box and use it for many fabrication tasks. It's not going to be as accurate as a laser level or something like that, but it's certainly going to assist with doing quick visual checks on whether or not things have been generally installed properly. And we've found it's incredibly useful for rethinking how we approach things like designing for tolerances. So we tend to design pieces of architecture or sculpture or installations or whatever it may be such that the design itself is from the onset trying to anticipate how it could be built within the tolerances and the precision of the HoloLens. And this is something that we'll be exploring quite a bit, I think, in this workshop. It's starting to think about not trying to make something sub-millimeter precise, but trying to make something that is wildly complex formally and maybe would be incredibly difficult to assemble, but is only 10 to 15 millimeters precise and that can be put together by hand. So it's this sort of rejigging of what we think is necessary tolerance in order to build very, very complex objects. Okay, so when you're working with the HoloLens in AR for fabrication, there's three key advantages that we find with working with this device that are important to think about, because when you're designing for mixed reality fabrication or augmented reality fabrication, I tend to use these two terms interchangeably, even though they technically mean slightly different things. But for the purposes of this workshop, we'll just use AR and MR interchangeably. But if you're designing for mixed reality fabrication, it's worth being aware that you are designing with natural user interfaces. So, for instance, if you were wanting to convey to a fabricator how to select a part in the model, you might design a user interface where that fabricator can go and literally reach out and pick up a part in order to move it over to a workbench and begin assembling it. Or if you design a button in a user interface, the worker might literally reach out and push that holographic button rather than needing to use something like, say, a mouse or any other UI element in order to interact with it. So there's very little abstraction, and that makes it's a very low barrier to entry to working with mixed reality environments. So we've found that even people without very much digital literacy, so they might not work with computers very often, they tend to be able to pick up and work with something like the HoloLens very easily because of the user interface being so natural, because they interact with digital objects on the HoloLens in the same way that they would interact with the physical world. The second key advantage to think about when you're designing for mixed reality fabrication is that you are typically designing shared experiences. So here you see two bricklayers wearing two HoloLenses, but they're looking at the same model in the same place. And this allows you to start thinking about how you might share skills and expertise between both designers and makers, or between different people within the fabrication team. So you could start thinking about how, you might have somebody on a team that might be, in this case, quickly putting down mortar where the mortar needs to go, and somebody else going through and laying bricks precisely on that mortar. And everything is always in the right place ahead of time because everybody has access to the same holographic information. Now, the third thing about designing for mixed reality fabrication, or the third key advantage, is that you, if you follow best practice, have precise location of digital content in physical space. So you can reliably see in three-dimensional space where a part is supposed to go, and you can use that as a guide or as a template in order to assemble things. So you don't need to use physical guides or physical templates or printed drawings as instructions for how to fabricate something. And this often means that actually producing design documentation becomes very, very simple. The design model and the fabrication instructions become closer to being the same thing, because the design model just becomes essentially a representation of what the finished product should look like, and everybody always has access to it in the context of where that finished product is going to actually be built, which fundamentally, again, changes the way that we can build things. Okay, and what is Fologram? Well, Fologram is software that lets mixed reality devices talk to Rhino and Grasshopper in real time and in a manner that is bidirectional. So what this means is that you can use Rhino and Grasshopper to build mixed reality experiences or applications rather than needing to use things like game engines to do the same thing. This does two things. One, it makes testing ideas very, very quick. So if you're already designing in Rhino and you want to find out whether or not you might be able to use your design model to be, as a set of fabrication instructions, it might take you under 10 seconds to view that model in mixed reality and test an idea. Whereas if you're working with a game engine, you're going to need to export your model, import it into the game engine, set up, do a build for the HoloLens, run that app on the HoloLens, and then look at it in physical space, which is a significantly longer turnaround just to view the model. What it also lets you do, though, is build quite powerful interactions using Grasshopper. So Grasshopper becomes what's known as an event-based modeling environment rather than simply a parametric modeling environment. So we use Grasshopper to start listening for events which are triggered by mixed reality devices, things like whether or not your phone is moving around, whether you're tapping on something, interacting with a slider. With the HoloLens, we might be doing things like listening for changes in the 3D scan of the HoloLens, observing changes in the gestures that a user might be making with their hands, And we're using those as parametric inputs directly into your Grasshopper models, triggering changes in those models, rendering some new geometry, and streaming it back to the phone or to the HoloLens. And this lets you do all sorts of really cool stuff, and it's what we'll be exploring in this workshop quite directly with you all. Okay, generally speaking, what we like to use this for, even though you could use Fologram to build all sorts of design tools, box modeling tools, blob modeling tools, literally you name it, you can probably build it with Fologram on your phone. Where we think the kind of most exciting use cases are for mixed reality, and it's why we're exploring this specifically in this workshop, are around actually making things. And so this is what we're going to concentrate on. And I wanted to give you an example of what I was talking about earlier about how this might affect design. So this is a sketch of a chair that I did in Rhino. It's a couple of years old now. And this model of the chair hasn't been rationalized really in any way at all. And by that I mean every piece of geometry in this chair is a different length. There are bends in this chair that are all different angles in three-dimensional space. None of the parts are rationalized into 2D planes. There's a lot of self-intersecting geometry in this piece, so it's not a physical model by any stretch of the imagination, but it conveys some design intent. So it's a particular scale, it's modeled off of the body, it has some kind of ribs for attaching some sort of surface to the top of the chair, there's places where it touches the ground, there's a sort of a formal language that I was interested in where things bundle. So, and for those reasons, to capture some of those ideas in the 3D model is actually very, very fast. This thing took about 20-30 minutes to model. But ordinarily, you would then spend hours and hours rationalizing it so that it could be built. And if it was going to be built by a fabricator that typically works in 2D, you might spend days rationalizing it into 2D parts, and the design would inevitably change quite significantly. Now, the exciting thing about working from holographic instructions to fabricate these things is the design doesn't really have to change. So this is the sketch, and this is the as-built chair. The chair, this one took about 7 hours to build by hand, using that design model as the fabrication instructions. So we didn't make any drawings, we just followed that three-dimensional hologram as a guide when we were bending pieces of steel. And the design model really only captures design intent. It isn't a kind of an explicit contract for exactly what needs to be built. And it gives the fabricator some agency during the making to make some simple design decisions. So for instance, when parts of this model were self-intersecting, we would move the pieces of steel slightly so that they weren't self-intersecting. Where parts of the model needed to be very accurate, like on the top of the chair, we would carefully follow the holographic guide to ensure we were getting maximum precision. And where they didn't need to be as accurate, like in the bundling structure, we would more quickly bend the parts and pay less attention to how closely we were following the hologram in order to reduce the fabrication time. And so I guess the kind of exciting thing here is that you can save a huge amount of time in unnecessary rationalization into sort of 2D geometry and planes. You can make the fabrication instructions extremely simple. You can make design changes during fabrication while still meeting the design intent of the author, and you can fundamentally invert the complexity of fabricating these sorts of formal languages and geometries from something that would have been time-consuming, difficult, tedious, and expensive. It suddenly becomes just as quick, easy, cheap, and fast as building something out of square, rectilinear, or sheet geometry. And this is really exciting, I think, for architects and designers. Okay, so let's step through 4 different approaches to designing and making in mixed reality, and a lot of these approaches we'll be asking you to explore specifically in these workshops. So the first one is conventional construction in mixed reality, things like bricklaying. So where you may not have the most formally complex geometry ever, like with that chair, you might be working with highly skilled construction teams, but construction teams that aren't necessarily highly digitally literate. And the goal is to try to reduce the time, cost, and risk of any non-standard construction. So buildings like this one by Frank Gehry at UTS in Sydney, they're exceedingly complex, costly, and difficult to build. And as a result, you don't see this kind of experimental architecture too often, just because it's not feasible. But something that we're interested in doing is trying to, just like with the chair, to invert some of these kinds of equations where experimental non-standard geometry is costly to build, and instead trying to bring it down to being similar cost and low risk to just conventional construction. So we'd done several workshops looking at analogous bricklaying, where you're laying repeating parts, rectangles of foam or something like that, following a holographic guide that shows you where each one of those components needs to go. When you look through the HoloLens, what you see is an outline of each component. So the green model here. Green, it turns out, by the way, is a really good color for holograms. There's a reason that heads-up displays in aircraft tend to be green. It's because it stands out from the rest of the environment without being too glary. But what you see here is a green outline showing the construction worker exactly where the brick needs to go, and he's pulling that physical brick and doing a visual check to make sure that that brick is in the same spot as its holographic representation. We'd done a few projects that were, quick and dirty to do. This one was a 4-hour build in Germany, several thousand foam bricks. Gives you a sense of the kind of precision that's possible with these approaches. So you're able to capture these qualities and effects that are almost entirely derived by very subtle, gradual changes in the position of each brick relative to the previous course. And we've gradually been kind of scaling up this technology and finding partners within industry who are willing to give this a go on real construction sites. So we did a small project, a feature wall. This is about a year and a half ago now, of 600 bricks. And much like with the chair that I showed earlier, with this project of 600 bricks, if it was to be built entirely conventionally by essentially measuring out where each brick would need to go in the wall, this would take about 2 weeks of construction time. And instead, using a holographic model, we bring that down to about a day of construction time. So these sorts of projects become quite feasible. And as a result, we had a go at doing a similar thing on a commercial project. Many more bricks, much larger scale. So this time working with benches, which are up to around 20 meters long, and using custom cut bricks. So a fairly large library of around 30 different brick types in order to make very smooth curving geometries that would then become these benches in the Royal Hobart Hospital. So in order to deliver this project, and this is something that, again, you guys will explore in this workshop, what we need to make is essentially holographic shop drawings that the fabricators can follow in order to reliably place the correct brick in the correct spot. And so what we do is we model every single brick in the wall using tools like Grasshopper. This is all parametric. You'd never ever draw this stuff by hand. And you're always trying to think about, okay, well, how am I going to set out this hologram on site? So we model it relative to some surveyor points on site that let us accurately position the hologram in the right place. And you start thinking about, well, how are the bricklayers going to be able to access the digital information they need when they need it? And that's where these really simple, big interactive buttons come into play that allow the bricklayers to just step through the courses in the wall. So when they've finished one, they can easily move to the next one without needing to go back and check a drawing or change a model on a computer or something like that. So this is what it looks like. not through the headset. This is actually, this image, full disclosure, is a mock-up. But we have a video with a bunch of footage showing what this does look like through the headset by the guys on site. So there's a few things here which were pretty exciting to us. One is that ordinarily when you're doing this kind of complex brickwork, you would have to have one person start laying bricks from one side of the bench and work their way around. You couldn't just start laying bricks arbitrarily from any point in the bench because you wouldn't get a consistent bond. You would end up with a kind of a smushy little gap somewhere along the bench, and you run the risk that that smushy little gap introduces a cumulative error that then means that you have to go through and undo a bunch of work. So what the hologram let us do, because it's a shared mixed reality environment, we could have as many guys as we wanted constructing the same course of bricks at the same time with significant time savings. The other thing that was pretty interesting working with Fologram on this project is the bricklayers were able to invent the tools that they needed to do the job faster. So with all of the cut templates for these unique bricks in the structure, they had a hologram showing them exactly what each cut template needed to look like, and they'd use a sort of scrap bit of wood on site and mark out exactly what that cut template needed to be when they needed it. They'd keep the HoloLens on, go grab a power tool, cut out the template, and then start making the bricks. And they'd never need to stop their normal workflow. So they're just wearing the headset all the time, and they're using the holographic information in kind of creative ways in order to deliver the job. And that's because they're skilled contractors. They know how to work with brick and deliver a really high quality result, and they know how to deliver essentially on the design intent when they have all of that design information ready to hand, so they can see exactly what the benches are supposed to look like, and then they can go and use their skills as tradespeople to build that as precisely and quickly as possible. There are a couple of other interesting things that happen on the site. One was that other trades had access to the same holographic information, so they could always whack a headset on, and in that earlier part of the video you could see a guy relocating some plumbing. They were able to check where that was going to go with the headset and make sure there weren't going to be any clashes. And we found that the brickies that were working on this project after using it on the hospital job, they're now essentially waiting for architects to take on some of this capability and begin specifying things in mixed reality so that they can do more jobs in mixed reality. And that's really exciting to us, that there's a push coming from industry for this kind of new technology, because it enables them to do more exciting work rather than the push needing to come from the design side. We're always asked by anyone in these sorts of talks and presentations how accurate the HoloLens is, and it's a really difficult question to answer just because it depends so much on the care and the precision that you're taking when you're following holographic guides. But in the case of this brick project, we were pretty careful to do a fairly rigorous empirical analysis of the precision of the HoloLens by building a prototype and 3D scanning it. And we were then able to compare the 3D scan to the digital model to work out exactly how precise it was. And we published a paper on this if you're interested in looking into it further. This image shows the scan overlaid over the digital model. You can see on the far side of the prototype where the scan's clearly not in the right spot. And it's really interesting to see this because that little chunk of the prototype was done without the HoloLens. The HoloLens ran out of battery and they just finished off the top course, and it's by far the most inaccurate part of the structure. The rest of the structure deviates between, I think it's about 5 to 10 millimeters over the course of this thing. So that's within construction tolerances for brickwork by far, whilst also bringing about all of those kind of time savings by being able to construct it in parallel. So this means happy bricklayers within the construction industry. So on the design side, there's a few interesting things that are happening as well. So we've been thinking about how, event-based modeling in Grasshopper fundamentally changes how we use traditional CAD tools. So you wouldn't typically make a darts game within Rhino and Grasshopper because it just wouldn't be that fun to play with a keyboard and mouse. But when you can pick up part of your parametric model in mixed reality, the first thing that you want to do is to throw it in order to understand kind of where the limits of this virtual world lie. Like, does it behave really like a physical object? Can you pick it up? Does it stop when it hits other things? Does it feel heavy? All of this sort of stuff. And it's very easy to build these kinds of applications in Grasshopper because you have access to some really powerful geometry tools within Rhino. It's useful for building games based off of physical simulations, for instance. And so I think that using these sorts of softwares, Rhino and Grasshopper, within mixed reality is going to fundamentally change how we think about interacting with our designs that we're producing in those softwares. Another thing that's really exciting is that when you work in mixed reality, you get collaboration for free. So normally if you're working on a Rhino model with somebody else, you would need to exchange files. So you would work on a file, you'd save it, you'd send it to someone else, they'd work on it, they'd save it, they'd send it back. This is really tedious, and it means that you need to be you need to understand how to use Rhino and Grasshopper to contribute to those sorts of design processes. Whereas it's very easy to connect multiple mobile phones or HoloLenses to one shared Rhino and Grasshopper model and have everybody interact with that model at the same time through mixed reality. So you need to understand how to use a phone in order to participate in a design process rather than how to use what are pretty complex interfaces of Rhino and Grasshopper. So you can imagine doing things like building kind of massing studies applications for doing city planning, or maybe doing shadow studies, or whatever it might be. All of that can become much more participatory. Another thing which it becomes a pretty exciting design tool is designing and modeling at one-to-one. So this is a little video of a kangaroo simulation running in Grasshopper and Fologram, and we're manipulating that simulation at full scale while that simulation's running. Extending this to other kinds of simulations, so we can control robotic arms in mixed reality. And there's some exciting things here by being able to combine, things that maybe people are good at with things that robots are good at. So maybe you could begin imagining workflows where a robot is precisely fabricating something, while a human is doing a very, very complex assembly task. So there's a huge opportunity here for using Rhino and Grasshopper as a sort of a control environment for robotic arms, or just as a visualization tool. So being able to visualize where a robotic arm is going to move before it moves there can significantly reduce the risk of some kinds of robotic fabrication processes. So that's those little projects there. They're sort of a side note. We'll be exploring some of those through examples in the workshop, but because they aren't specifically tied to fabrication, they're not necessarily what we're going to concentrate on this week. So another theme is this idea of augmenting analog machines. So trying to use mixed reality to add digital precision to very cheap analog tools. So in the bricklaying example from earlier, or even in the steel bending example, those are very much just manual processes. You pick up a part and you place it down where you see a hologram of the part. The user interface is very, very, very simple. But we've gotten really interested in this idea of making user interfaces that are a little more sophisticated in order to fabricate parts in mixed reality. So one good example of this is doing rod bending in mixed reality. We'll show this definition to you guys in the workshop. Specifically making a tool that lets you fabricate splines or polylines by showing three-dimensional bends overlaid over a tool that is going to actually be doing the bending, and building a really simple interface that let you step through those bends as and when you need them. So this is a little video showing how that works. This is from a workshop that we did in Tsinghua in Beijing a couple of years ago. Very, very simple, cheap, analog rod bender. a hologram overlaid over that bender that just shows you where and how to bend a part into really any shape you can imagine. So rather than using machines to bend these sorts of parts, which are potentially faster and potentially more precise, what this allows you to do is to fabricate parts with an incredibly cheap tool and in a way that's very, very resilient to the need to change things over time. So when you're bending something with a rod bender, sorry, that video is the same. When you're bending something with a rod bender, typically you have to deal with something called spring back. So for each bend, you need to overbend it slightly to accommodate for the elasticity of the steel. And when you're fabricating something with a machine, you need to estimate this spring back and encode it into the instructions for the machine so that you get the part you want. Whereas when you're fabricating something following a hologram, you can just intuitively adjust the thing that you're bending until it matches exactly what you want. So you're able to change things while you're making them in order to accommodate for material that is a little bit tricky to work with. And we got really, really excited by this idea and explored it in several other projects, which I'll talk about later. Another extension of using very, very cheap analog tools combined with the sort of digital precision of holographic models is in being able to digitize physical things while they're being built. So when you put a fiducial marker out in front of the HoloLens or in front of a mobile phone with Fologram, you can track exactly where that marker is in space. And if you run it along a physical object that you want to digitize, you can get an approximate sense of the geometry of that object. So while we were fabricating those bent parts and assembling them into a structure, we had another team that was taking these sample points using this tracked marker in order to essentially remodel from the physical object a digital model of the as-built structure. And this would allow us to do things like compare the precision, like how closely our as-built object matched our initial design model. So this was the initial design model, that's the digitized model, showing the deviation, the as-built model, and then a photo of that. So it gets you a sense of just how precisely you can make, you know, very, very complex forms using incredibly cheap analog tools entirely by hand. One other thing that we'll explore in this workshop, and this is something that we're always sort of curious and excited about, is tracking physical tools during making processes. So being able to provide some feedback to the person who is using the tool in order to help them, you know, follow much more potentially complex fabrication instructions. So this is a little video of a tiny short project that we did a little while ago where we're tracking a hot knife while we're carving a piece of foam, and we're changing the color of the digital hot knife based off of how close the physical hot knife is to the digital hologram that you're trying to cut with it. So it's really blurring this distinction between a physical object and a digital object, and providing some feedback to the fabricator that lets them essentially reduce the chance of cutting something in the wrong spot. Because the challenge of subtractive fabrication processes is once you've removed some material, you can't easily put it back again. So you need some really clear feedback to help you reduce the chance of those mistakes. Also, with subtractive processes, it's just difficult to use a hologram as a guide. And that's because judging depth perception and things like that can be challenging. You don't get perfect occlusion of your hand or the tool with the hologram that you're working with. And so having some color feedback showing you how close you are to doing the right, performing the right task is really, really helpful. Okay, last project to talk about over the next 10 minutes or so before we try to do a handover of the live stream from where I am in Melbourne to where Sean is in Melbourne, hopefully without too many technical problems. The last project is the recently completed pavilion that Sean also worked on over in Tallinn. And this is actually worth pointing out. This project was a collaboration with many others. So with Sumin Harm and Igor Pantic from the Bartlett, and with format engineers, as well as a huge team of really, really generous volunteers that came and contributed their time to help us build this project, and several universities, including Aarhus and Temple, who helped with prototyping. Now, with this project, something that I wanted to talk about was to come back to what I was describing earlier on with the chair, and how designing for holographic construction, we really should think differently about the necessity of having extreme precision, and how in order to deliver on, certain types of design intent, let's say in this case it's kind of trying to capture fluid form, it's trying to build off of a language of difference, many slightly different parts repeating themselves in order to make up these kinds of wildly complex shapes. In order to deliver on these, we don't necessarily have to perfectly fabricate every part as it matches a design model. And in fact, design models might even become approximate or fuzzy representations of a thing that can be built, if those approximations and representations are within the tolerances of the material that will be used to fabricate the structure. So with this project, it was about trying to use mixed reality as a kind of a guide for steam bending timber parts. So we would have a hologram showing us the shape of a piece of timber that would be part of the building, and we would maybe have a hologram showing us roughly how to set out some formwork for that shape. You would then place the formwork where you saw it on the hologram and bend a piece of timber until it was the same shape as the hologram. The main idea here is, typically with steam bending, it's an incredibly time-consuming, difficult, expensive process, because you have to fabricate a mold for each part that you want to bend in order to try to minimize the springback and maintain a kind of a predictability of the bent timber. Whereas we were kind of hoping that by having, much like with the pipe bending, by having a holographic representation of what the finished part would be, we would be able to continually adjust the timber while we were bending it in order to make sure that it closely matched a holographic representation, regardless of whether there was springback or unpredictable behavior of the material. So following this idea, we started exploring some pretty crazy schemes. We thought, well, we'll just be able to bend just about anything. So, maybe this thing could look like a bird's nest, or maybe it could look like something which is, brushed hair consisting of many different types of material. Maybe it's sort of more volumetric. These gradually got rationalized within the sort of process of doing the competition. We did this over the course of about a week, I think. Trying to make something that was more surface-like in order to reduce the amount of material, putting this thing together into something which is maybe more architectural, trying to frame up views of the site to find some inside-outside spaces, play with conventional ideas of, things like walls or things like columns. And this was the eventual proposal that we came up with for the site in Tallinn. And when we submitted this proposal, we actually had no idea really how it was going to be built. We'd done very little steam bending before. We'd never built anything of this scale from mixed reality instructions before. This thing was about 10 by 10 by 5 meters, roughly. And so we were incredibly grateful and appreciative of the competition jury giving us an opportunity to work out how to build a structure like this, given that it's fairly high risk and it was something that was very, very new. Just a few more images showing the complexity of this thing. And this is the competition model. So I always like showing the competition model because it gives you a sense of how closely we managed to match the original intent, but also how completely unrationalized the sort of the first sketch of the project was. So, a whole lot of this geometry, again, like the chair, is self-intersecting. There's not really any consideration of how this thing could be supported and stand up. There's no rationalization into a small number of parts, things like that. So we're really starting from what is purely a design sketch. There isn't necessarily a lot of fabrication logic embedded in this project to begin with. Now, one of the first, things that we had to overcome, and that we'll just continue discussing these sorts of ideas throughout the workshop, I think, is how you manage the spring back of the timber. And again, this is why I think steam bending hasn't been overly commonly used as a fabrication technique. So on the left, you see a piece of timber on a jig that Sean and I designed that was essentially set up following a hologram so that you could bend a piece of timber over it into a precise shape. And on the right, there's a little GIF showing you, the black strips are the piece of timber on the mold, and the red strips are the shape of the timber when you take it off that formwork. And they're very, very different. So if you didn't have a holographic model showing you exactly what this part was supposed to be, you would need some other kind of jig or template, or you'd need a lot of measurements just to be able to check whether your parts are even correct. And so this was the first challenge, was overcoming this spring back. So we started modeling some of the timber material behavior and trying to essentially simulate overbending of the timber. With this model, we did some large prototypes. This is with Andrew Witt at Temple University. And the prototypes failed catastrophically. They were nowhere near the precision that we needed because the springback was just far too great. So even though we could see what the shape of the parts was supposed to be as a hologram, the physical timber just was not matching the holographic parts. We weren't able to bend it to match the holographic representation. And so we needed to start thinking differently about how we would design for this type of holographic construction. And what that effectively meant is designing really, really long parts. So in the first prototype, we used short parts. In the second prototype, we started using 12-meter long pieces of timber. And the reason for this was when you have a 12-meter long board of timber, even though it's sort of 15 millimeters thick, and you'll get some springback, the springback doesn't exceed the natural elasticity of the timber. And so we ended up building this pavilion from floppy material. So we're not making it from rigid material at all. It's almost like putting together a piece of a pavilion from a whole lot of spaghetti that just flops around until you pull it into the right shape, using this kind of composite shell of these weak timber strips and weak steel elements that I'll show you in a second. And so because you're constructing from something which is really, really floppy, this just would not be possible to construct in any other way without having literally a mold or a framework for every single part in the structure, which would be far more costly than the part itself. So this is a chunk of the pavilion. It shows you roughly how this structure works. You have these very, very weak, flexible grey timber strips that are reinforced by very, very weak, flexible red stainless steel brackets running in the opposite direction. This is a hologram showing how each part was laid out. So you have a 12-meter long part, or this one's actually slightly shorter. It's maybe 8 or 9 meters long. And what we did is these parts needed to be assembled from 3-meter long lengths of timber. And the timber we had was very cheap. It was full of knots, and it would easily break if you were over bending it. And so what we needed to do is display on the HoloLens where the timber part was going to be bending a lot, which is the red areas, and where it was going to be relatively straight, which is the green and yellow areas. And then when we were placing the lengths of 3-meter boards to make up these 12-meter long parts, we were able to make sure that the timber that had knots in it was always being placed in the green parts of the piece, rather than in the red parts. So you always have a hologram showing you not only the shape that something is going to be, but also the sort of the performance of that part, how it's going to behave during the shaping. And this was essential because we didn't have enough time to break any parts. Steam bending takes about a day to form a part and dry it out. And so when if you break a part, then you need another day to fabricate it again later. And we were on such a tight fabrication schedule that wasn't possible, so we needed to use these sorts of holographic guides in order to minimize the risk during fabrication. What this image also shows you is that for every single strip in this structure of the pavilion, they're all made from the exact same stock material. So there's no prefabrication other than just laying up planks into a straight strip, as I just mentioned. There's no prefabrication of these parts really. None of them are cut into any unique shapes. They're just a piece of straight timber. And this is a kind of a key idea. It's being able to form very, very simple standard pieces of material into very, very complex, unique shapes without generating any waste at all, and keeping a very short production chain, which keeps things very flexible. So if for any reason we did break apart, we would always have more material ready to reform into that same part again, again reducing our risk. Whereas if we had to CNC cut anything, we would have to reproduce our cut files, send them off to the fabricator, get them cut, wait for them to come back, and then rebend them. And again, we just didn't have that kind of time. So here's a short video showing you the actual fabrication process. This was fairly early on, I think, in the fabrication. And what you're seeing here is this is filmed through a mobile phone actually, but Igor is wearing the headset, and he's following this red strip which shows him the shape that this board needs to be while we're steam bending it in a bag. So essentially you have a 12-meter long bag with a 12-meter long part in it that allows you to keep the part really, really hot, which massively increases your work time. So if we took this timber out of the bag within sort of 20 seconds, it would be too cold to bend. In the bag, you get more like sort of 5 minutes to bend the part, which lets you keep it fairly accurate. I think there's another video after this one. Yeah. This gives you a sense of some of the geometry that we're following. Now in this video you can see there's no formwork marked out, and this is how we ended up bending quite a few of the parts. So we didn't even need to model the formwork in Rhino. All we had was the hologram of the strip, and this is a very, very simple NURB surface in Rhino. And then we would use that hologram to figure out how to place the formwork just intuitively. And so this really reduced the modeling time for the project. It meant anyone could place the formwork. So you whack on a headset, you see where the hologram is, and you start putting down these pieces of timber just so that they match the shape of the strip at any one place. And it also let us work within the tolerances of the fabrication process. So when you're steam bending these very long pieces of timber, because the timber itself is floppy, you don't need to make something exactly accurate. This needs to be accurate to within a couple of centimeters, but any more than that, and it's not actually worth pursuing just because of the flexibility in the material. And so not having a hologram showing exactly where the formwork had to go just made setting out these parts far, far, far quicker. And it's kind of an interesting idea because this is a complex double curved piece of geometry, and yet again there's almost no design documentation required in order to fabricate it. You just use literally the 3D model from the design oriented flat on the floor in order to fabricate it. Now the other thing that we used a hologram for, which we'll talk about in this workshop as well, is fabricating these steel brackets that fit through the structure. They're incredibly complex things. There's a whole lot of work that went into making them possible to build, but essentially the brackets need to join the timber boards together, and they need to be buildable. So you can't have very, very tight angles, or you wouldn't be able to bend them with a bender. You can't have very, very short bends, or they won't fit in the bender. They need to touch the surface of the board by a certain amount in order for it to work structurally, etc., etc. And so we ended up using a physical simulation in Grasshopper, just using Kangaroo in fact, that we're happy to show you guys if you're interested, in order to simulate all these fabrication constraints. So to make sure that the bend angles were always within what we knew we could bend, and to make, as well as maybe 10 other fabrication constraints like that, and to make sure that our steel part would unroll into a straight strip so that we could just use stock lengths of stainless steel to manufacture all of these brackets. And this again just saved an enormous amount of time and money because we didn't have to laser cut or CNC cut anything for the project. So all of these steel parts are just made out of lengths of stainless steel, even though they're all three-dimensional and entirely unique. This is the holographic model with the bending. It's very, very similar to the one that I showed you guys earlier with the pipe bending. So you have a couple of buttons which will allow you to step through specific bends in the part. You have a hologram overlaid over this really cheap bender showing you the geometry before and after each bend. So you can essentially line your part up with the before geometry and then bend it until it matches the after geometry, which is what we're doing here, so lining it up. Again, the steel has some flexibility in it, and also these images are taken through a phone, so they don't perfectly reflect what you see through the HoloLens. HoloLens is a little better aligned to the physical model. But they give you a sense of what you're essentially doing as a fabricator, and these parts are in 3D. And then similarly on site, because everything is flexible and floppy, you really constantly need a hologram showing you exactly where each of these parts should go in 3D space in order for the structure to work. And this is critical because we did a whole lot of, or format engineers did a whole lot of really fantastic engineering on the structure. They predicted how it would sag and deform. And so we're working with a structure which is a shell, and until the shell is complete, until all of the parts are in place, you're really working with something which is very unwieldy. You've got these 12-meter long pieces of timber up in 5 meters up in the air. They're moving around a lot. And so without having a constant reference to where things should be, it's very easy to place a part in the wrong place, screw fix it, and then deform and pull the entire structure out of the shape it's supposed to be, and you start then running the risk that the engineering calculations aren't actually going to perform as they were intended to. So a couple of images and then quick videos of the completed project, just to give you a sense of how this thing is both similar and different to the original sketches that we conceived of. There's a lot of rationalization in the project in the end, in terms of how this thing touches the ground and in terms of trying to fabricate it out of really, really long 12-meter parts rather than many, many shorter parts as we originally planned. But I think the design intent is very, very close to the original sketch. And this is really the kind of the compelling argument to mixed reality fabrication, is because if you're thinking about designing for mixed reality fabrication, you can start thinking about reducing the need to rationalize your parts into, let's say, 2D models, or reducing the need to document for digital fabrication, as well as starting to think about how things like tolerances might be able to be tweaked or eliminated. So, if you're working with flexible materials, maybe you don't work within 1 or 10 millimeter precision, but instead you ensure that the whole structure is accommodating of maybe 20, 30, 50 millimeters of precision in order to be able to build something by hand. So here's a couple more images of parts of the project. Okay, so that hopefully gives you a kind of an overview of some of the approaches that we've been taking to digital fabrication in mixed reality. And what we're going to do is explore these themes over the workshop. So we'll be looking at how you might fabricate kind of timber structures in mixed reality, how you might look at doing projects which are maybe more like conventional construction, so assembly from repeating parts, things like bricks, stuff like that. We'll look at some subtractive fabrication, so showing outlines of structures and tracking tools in order to fabricate things from clay. And we might also, take some ideas from you guys if there's something else in particular you'd like to explore. So Sean, I'm going to stop streaming now. For everybody else, we might have a 1 or 2 minute gap in between the streams. And I think that it's probably a good idea for everyone to take a 5-minute break. But we'll try and get Sean on first. He can introduce himself, and then we'll we'll work out what's happening next. So thanks very much, everyone. I'll be on the forum and on the chat. If you've got any questions, happy to keep answering them, though it looks like Sean's been doing a good job of answering them while I've been rambling away here. Yeah, enjoy the rest of the day's tutorials. Catch you later.
Okay, so looks like I'm live. Thanks for that, Gwil. I hope you guys all found that to be a really insightful kind of insight and introduction to Fologram. Just want to make sure everyone can hear me okay. Can someone just give me some life in the chat? And then I'll just quickly introduce myself and talk through the next part of this workshop. Cool, all right. I just got the we can hear you message, so thanks for that, Shivam. Look, firstly, I'll just introduce myself really quickly. So my name's Sean. I'm the Fologram for Rhino product manager. I play a large role in developing applications and solutions for users of Fologram. A bit of my background, I hold a Master of Architecture from RMIT University, and I've got a background in algorithmic design and advanced fabrication. So I've previously had industry experience in large-scale 3D printing and robotic fabrication applications for permanent building structures. And I've also previously held academic leadership positions at universities in Melbourne, as well as the AA. So in terms of how we're going to go from here, what I think we'll do is, as Gwil was saying, because that was, I think, a good hour-long intro for everyone to Fologram, we might just have a 5-minute break if you want to go and get a coffee or have a glass of water or something, and we'll reconvene in 5 minutes. Basically what we're going to get stuck into is using Fologram. We're going to be using the mobile application. So if you haven't downloaded the mobile application, quickly give that a go. Also, just as like a last little thing, just quickly, if you can, download the Fologram for Rhino plugin. I'll probably talk about that a little bit as well, but let's reconvene in 5 minutes or so, and then we'll get stuck into all of that. All right, cool. So I think we should try and get back into it. Just give everyone 1 minute and then we'll get straight back into it. All right, cool. So on my screen, as you can kind of see, I've just got the Fologram community forum open. I just want to start by quickly talking through this because basically if you've got an issue or you want to ask a question or you want to get in touch with us or any of the people in this workshop over the next couple of days, we think this would be the best platform to do it because it gives a platform for everyone to kind of engage in. So it's just community.fologram.com. You can also access it from the fologram.com website. So in particular, I want you to focus on the workshops category or forum or sub-forum of our community forum. We've got a little Digital Futures 2020 board set up where this is going to contain basically all the content and all the questions and things that you need to do this course itself. So last week I went and posted a couple of quick little links and resources. The first thing I'll just quickly talk through is the outline. So most of you would have read this outline in terms of the course description and the workshop objectives and outcomes before you signed up to the course. So most of you will understand what this course is about, and you'll have a greater understanding of what we do based on Gwil's lecture. Just in terms of the workshop schedule, I just want to clarify a couple of things with everyone just for the next 3 days. So we're going to be starting at the same time every day. We're probably going to run for approximately 3 hours. I'd probably say it'll be a maximum of 3 hours any session will go for. Some might actually be a little bit shorter than that, but it'll be at the same day every single day until this coming Thursday. And it'll always be running on the Fologram for YouTube channel. So it is our intention to post these videos on the Fologram for YouTube channel. So if you do miss something, just feel free to get in touch. Of course, whilst there is a live stream going on right now, you can definitely ask questions in the chat, but if there's a much more detailed explanation that's needed, we'll probably send you to the forum, so just be aware of that. So in terms of today, what we're going to do is we're just going to get our hands on the Fologram for mobile app. So it's obviously available on iOS and Android devices. And we're just going to explore kind of like a little bit of an introduction to Fologram and Grasshopper on the Fologram for mobile application. And then we're going to build like our first kind of interactive and simple augmented reality or mixed reality application just on our mobile phones. So what we're actually going to do today is we're actually going to build eventually a little kind of timber bending or steampunk simulator where you can kind of design your own little steampunk aggregation and view that and manipulate that in AR. On the second day, we're going to start looking at fabrication sequencing using Fologram. So we're going to learn how to create sequences and fabrication instructions. We're going to look at that through the lens of both the timber bending and some of the brick stacking projects that we've worked on previously. Day 3, we're going to look at a further developed design and fabrication workflow using mixed reality applications. And in particular, we're going to take a broader look at some of the different tools that are available to you in Fologram. Those include the tracking components and things like global variables within Grasshopper. So you're going to be able to interact with your designs live from your device and augment manual tools for fabrication, at least create a workflow for that process. Then on the final day, we're going to look at the subtractive workflows that Gwil was talking about in the lecture. And then we're going to have a bit of reflection on the things that we've done over the course of the 3 days. And during all of this, we're hoping to create or curate a little bit of a virtual exhibition space, but we'll talk about that a little bit tomorrow. So once again, as I mentioned, on the Digital Futures board, there's a bunch of other resources. So just if you haven't already, it'd be really great if you could go to these other 2 posts, which is aligning models to physical space in Fologram, and download these 2 files, which is a little 3D model of the Barcelona Pavilion and a QR origin code file. So if you haven't done that already, go and download those. And then there's also another little Grasshopper file and image file under interactive timber bending. So just in here, go and download this image, so this timber image, and also this field design template, because we'll use that as we move through the workshop today. So what we're going to do first, I might just get Rhino. We're not going to use Rhino straight away, but we'll probably start using it pretty soon. But I want everyone just to begin by opening the Fologram application on their mobile or tablet device. So I'm just going to quickly stream my mobile phone to the screen so everyone can kind of see what's going on live on my device. So there's my phone. I'll try and get it out of the way of my head. Sitting just above my head there, like that. So then you can clearly see what's going on in my device at all times. So I'm just going to open up the Fologram application like that. So as just a reminder again, if you haven't already downloaded it, available on the App Store or Google Play. On the first download, the application's free, and basically you can use the application and all of its features for free. There are two kind of extra in-app features that you do need to pay a subscription, like a premium subscription for. These two features are not necessary for this workshop, however, but I'll talk through what they are in a little bit more detail later. When you first open the application, make sure you just enable the microphone and video settings of your phone access to Fologram. Otherwise you won't be able to use the application properly because you need obviously the screen to do this. So when you first open the application, you'll get a little screen that looks like mine, and it kind of like prompts you with a little message that says scan a QR code to connect or load a model with the button below. So we're going to look at the scanning a QR code thing a little bit later on. What we're actually going to do first is we're going to load a model, a predefined model that comes with the application itself. So if I go down to the bottom of the Fologram app interface, you'll see like these two little squares with a little house on one of the squares. And this is where our saved and loaded models sit within the Fologram app. So I'm going to go ahead and just press on that, and you'll see I bring up the models menu. So I previously talked about two features that are available to premium subscribers for the mobile app, and we'll just quickly discuss one of those now. So saving Rhino models onto your device so that you can take them anywhere you want, that's a premium subscription feature. So if you've got the free version, you can't actually save models. I'm currently using the free version as well, but if you were to pay for the premium version, you'd be able to basically load up a model in Rhino and then save it locally onto your device and then take it anywhere with you as you move forward. So what we're going to do is we're going to go ahead and select one of these three example models. The one that I'd like you all to have a look at is the Via Savoy example model. So let's go ahead and click on the Via Savoy example model. So straight away the models menu is going to disappear, and it's going to ask me like a little prompt to move around to map your space, and then it says that mapped surfaces will display as grids. So basically what you need to do with Fologram is you're trying to create a little bit of a 3D model of the space around your physical environment so that your phone can go and place holograms on it. So I'm going to pick up my phone and I'm just going to scan my environment just slowly, and you'll see like a little grid appears, this little hexagonal grid, and that's tracking like a surface, which is my desk here at the Fologram office. I could also go out and try and track the floor, and you'll see I get a grid over there on the floor. There's a couple of little kind of tricks to this. So generally speaking, you want to have kind of a nicely lit room. You don't want to be sitting in the dark, or else you won't get enough light to track. You also want to try and avoid using black surfaces. So you see here I'm tracking on a black surface. Sometimes the mobile app struggles to track these surfaces. That's why I pasted down a couple of pieces of white paper onto my desk just to make that tracking a little bit easier. So the model's just going to follow my location the phone's aiming at once it's registered a plane that it can actually track on. And I'm also prompted to tap on the grid to place your model. So once I'm happy with a spot that I want to place it, I can just go ahead and tap, and it'll locate that model in physical space. And you can move around this model now as if it were there, as if it was sitting in the room itself or on my desk itself. If you've tapped and placed your model in a position that you're not happy with, don't panic, because it's really, really easy to replace the model, and I'll run through that now. So I'll just put my phone down here. You can see my Via Savoy. So once we've placed the model, one thing you'll notice straight away at the bottom menu is that we now have access to all the other menu options on the home screen. So previously these were grayed out and we could only really select the load or save model option, so the little house with the two white squares on it. But now we've got the ability to go and select some of the other options. I'm going to talk through them one by one as we go through this session today, so that you get a feel for what every single one does in this. So the first thing we're going to talk about is the edit menu, and the edit menu is the square at the bottom right, which is just the four corners of the square. I'm going to go ahead and just click on it, and that'll bring up the edit menu. Now, one hint I want to put out there straight away is whenever you see this kind of square grid that kind of fades off into the distance, that means you've got the edit menu open. So it's important just to note, because sometimes it's easy to try and do something in Fologram, like interact with an application, and you end up like editing the location of your entire model because you've got the edit menu open. So just be aware that you've got the edit menu open. Obviously the edit menu interface is appearing, but also you have this fading grid that appears at the bottom of your model as well. So just be aware when you've got the edit menu open. This menu is going to allow us to do things like reset our placement location. So if you're unhappy with what you just did, we can easily do that. You can move your model around, you can rotate the model, or you can scale the model, or then you can register the model at a specific location in physical space. So firstly, let's just try resetting our placement location. I'm going to hit the reset button, and it'll basically behave in a similar way to what we had before when we were just getting those grids, and we could go and place it on any of those grids. So I could go and try and place it, at another grid. If I'm not happy with it over there on the ground, I could hit the edit menu again, reset, and place it back on my desk. I could go edit menu again, reset, and place it up here on my computer screen, because I'm able to actually track it on my computer screen, and kind of et cetera, et cetera. So I want everyone just to have a quick minute playing around with the edit menu, just getting a feel for turning that placement on and off, and then placing your model in physical space. So try having a go at placing on a couple of different spaces in your room. I'd highly recommend, if you can find a flat space like my desk here as well, to use that during this workshop, because you'll be able to much more accurately place, and it'll just make your phone, make it much easier for your phone to track a flat space for the placement of your model. So once again, I'll just give everyone a quick minute, just have a quick go at placing a couple of different positions in your physical location. Cool, so if you're comfortable with that, you can also move and rotate and scale your model, and you can do this kind of natively just whilst you're in edit mode. So if you watch my application, I'm just going to jump into edit mode, and once you've got that grid that I was talking about, that fading grid that goes off into the background, we could go ahead and just try and like swipe and drag on our mobile screen, and you'll see that we're able to actually move our model around based on a little purple cursor on the XY plane of this tracked surface. So you can go and drag your model into place if it's not quite in the alignment that you're after, really easily. So the other thing that you could easily do as well is we could rotate this model around. So say if I wanted to align it to the edge of this desk a little bit more, what I would use is I'd use two fingers holding down on my screen and dragging. So what I'd recommend you do is you put two fingers on your screen on the far left of your screen, and then drag to the right, and you should be able to rotate your model just like that. So with a combination of rotating and moving, you could go and align it to the edge of like a desk or something, so it sits nicely in your space. And then the third thing, of course, I was talking about that we can do is we can easily go and scale this as well. So scaling is basically just like, zooming in and out on Google Maps. You use a pinch gesture. So if I pinch smaller, I'll get, a lower scale. You'll see in the bottom right, or not the bottom right, just below the edit menu, you get a little indication of what the scale is. So that's 1 to 100 that I've just scaled to. What we initially had the model at was 1 to 50. And of course, if you really wanted to, you could go and scale it up to, 1 to 1. I'm going to go back to 1 to 50 because it's a nice kind of size for the model to sit under my desk. But like I said before, just be aware when you're in the edit menu because it is easy to try and interact with your model or your Grasshopper application and then be in the edit menu and then accidentally just move your model off into the distance somewhere. So everyone just have a quick go experimenting with those movement, rotation, and scaling tools. I'll just give everyone a quick minute just to get a feel for how they work because we will use them a little bit, or those gestures, as we move forward in this workshop. Yep, sure. The rotation again, I'll explain that because it is probably the trickiest one. So make sure you've opened up the edit menu, that's the first thing. And then you just want to have 2 fingers and drag across your screen. So I'm basically, you can kind of see it, there's 2 little dots on my mobile. I'm basically just dragging across the screen. I highly recommend you start at the left of the screen and then you kind of drag to the right and you should be able to rotate that model. So let me know if that solves your rotation of your 3D model. It is a little bit of a trickier one. The other ones are much easier to do, but just dragging with 2 fingers across the screen should enable you to rotate your model in AR. Okay, cool. So now that we've got a model loaded up in Fologram, we can easily start creating content from this. So we can start creating like image capture or video or media, generally speaking. So most of you have probably thought about this already, but obviously the large circle in the middle of the user interface at the bottom is going to allow us to take a photo. So if I tap on that once, you'll see that I've saved an image to the camera roll on my phone. But I could also go ahead and hold that down and start taking a video, and your phone should vibrate and you should be able to go ahead and create a nice video of your model. You could go straight into it and start looking at the interior spaces as well, almost give like a little bit of a virtual tour of the Via Savoy, and then you just tap that again to end the recording. So you don't have to hold down the whole time, just hold down once until it vibrates, and then you should be able to capture a video of your session in Fologram. So that'll go ahead and save it to like your camera roll, or I can't remember what it's, I think it's your gallery in Android, and then you can go share it with all your friends on Instagram or something like that. But we might actually ask you to create a little bit of content after today's session. Yeah, so I'm just seeing on the chat, Gwil's responding to it, but we'll talk about the undo in a little bit more depth as well, because I'm guessing you're trying to move a bit of the geometry around there, which is kind of interesting and fun, but also highly dangerous. Before we just talk about that though, because I will talk about that in 1 second. I just saw a little message, you can't record without storage permission. So you just need to enable access for Fologram in your settings to read and write and capture photos to your device. So it's kind of like enabling the camera. So you just need to enable the permissions in your application. So that's kind of like an interesting intro to the edit menu and how to do video capture. The next menu I want to just quickly discuss is the layers menu. So this is the icon. I mean, if you used any kind of Photoshop software or something, you'd be pretty familiar with these types of icons. But this is the icon with the 2 diamonds. It's second from the left. I'm going to go ahead and tap on that. and you'll get a little bit of like a half screen that'll appear. You might get a little bit of a tracking issue, but just lift your phone up or move it and it should resolve that. And now we've got the layers of this model just appearing nicely on our screen, so we can go ahead and start manipulating it. So I could go ahead and start turning a few things off. Maybe I'll turn the walls of the Via Savoy off. Maybe I'll turn the slabs off. And then suddenly I've got like almost a skeletal version of this building sitting here on my desk, and I've got total control of it through my application. So obviously this gives you a lot of power and control if you were, say, using it as a presentation model to, say, a tutor or a client. And you could easily, you know, show options or show different parts of your building by just quickly toggling things on or off in the layers menu. I'll give you another quick, 30 seconds or a minute just to experiment with some of those layers, turning them on or off. So I might just turn all of mine back on for now. So we've got a full Via Savoy building appearing there. Okay, so I'm guessing quite a few of you have already figured out this next bit that I want to talk about, so I'm going to close that layers menu. But you can also interact with geometry in your AR session in Fologram. Now do this with caution because it can get quite messy, and I'll talk through some of the pitfalls of this as well. But I could easily just go and select on this slab and just pull it up and move it out of the way, and then I can go and see inside of the model. So I'm suddenly interacting with my geometry inside of the application. So I think this is one of the questions that was just coming up in our chat, is how would you undo this? So just be aware that there isn't an undo button currently in Fologram. So especially if you've got a saved model, if you go and do something wild and wacky like this and move it out of the way, or say we try and rotate it with 2 fingers or scale it with 2 fingers, you can't just go and undo that easily. Once we learn how to create a live link between Fologram and Rhino, which we're going to do shortly, you can easily undo in Rhino, and that obviously updates back to your device. But especially with offline models, you can't undo these kind of transformations inside of the Fologram application. So if you do something like that, generally you might actually just be stuck with, this weird kind of geometry sitting on the ceiling. So just be aware of the pros and cons of doing that. Maybe just have a quick, experiment, rotating and scaling one of those top slab pieces. It doesn't matter too much now, but just to give you a feel for how you might move a geometry around on your device, not just moving, but also, scaling and rotating it as well. So one last menu I want to talk about. There's one menu I haven't talked about, and we'll talk about it later on, which is the bottom left menu. But what I want to talk about first, more immediately, is the settings menu. So the settings menu is the little gear icon here up on the top left of the application. So if I go ahead and I open that kind of gear icon, basically we're going to be given a whole set of different settings that we can apply in the app. So one thing that I highly recommend you turn on straight away is the shadows. So the shadows make your model look like pretty amazing comparatively when they're off versus when they're on. So right now I've got them off, and it's a little bit of a Nintendo 64 kind of building that we've got there. But if I turn the shadows on, suddenly we get a little bit more depth and realism coming through. So I highly recommend in the settings menu going and turning on the shadows straight away. We've obviously got a restart button. You can do a soft restart of the application. The subscribe button will enable you to, buy the premium version. Say if you wanted to save models offline, you could sign up for a premium subscription to the Fologram application straight through the settings menu. And then one other thing, if you ever experience any crashes or huge issues with the app, just go to issues and suggestions and log an issue or problem that you've had, and we'll try and get in touch as soon as we can to try and assist on that. So those are the main things, or the main kind of interfaces and menus that I wanted to talk about just quickly as a brief introduction to the application. Let's take a quick 2-minute break because we'll jump into the next bit of the workshop after this. We're basically going to start trying to create a live connection between our mobile application and our Rhino session itself. And I should also say, just if you're having any issues, obviously just chuck a line in the chat, in the YouTube chat, and we'll try and help out with those problems that you might be having. Okay, so in the next little part of this workshop, what we're going to do obviously is create a live link between our mobile device and our Rhino session. But just before we do that, I just want to quickly talk about a few tips for preparing models for AR, in particular for using Fologram. So the first thing that you want to do, or make sure that you do, is you have your device on the same Wi-Fi network as your computer. So for example, my computer is on the Fologram Wi-Fi network. I just want everyone to go into settings on their phone, so I'm going to do it myself. Go into settings and just check your Wi-Fi. Just make sure that your Wi-Fi network on your phone is the same as your computer, because it's important that that's the case, because we're basically creating a connection over the Wi-Fi when we're connecting live to Fologram itself. I also want to give you guys a few tips on how to prepare your models for AR presentation on your phone, or AR fabrication in general, because it's not as simple as saying, like, if you're in the middle of a design phase in whatever your profession is, and you've got like a work in progress Rhino model, you've created lots of options and lots of different things, you don't want to just go ahead and connect that model up, because there'd be issues with like the file size, there'll be massive layer issues that you have because you're just quickly trying to iterate things. You'll have situations where your geometry is like hundreds of miles away from the origin point, so it won't show up in the right spot. So there's a few things that you want to do when you're preparing a model for mixed reality in Fologram. So there's a really great article that Nick Vandenberg, Fologram's CEO, has posted up on the Fologram community forum, and I highly recommend you all kind of go and have a quick read of this. But basically, one of the things you definitely want to do is to optimize your geometry in your model. So Nick kind of talks through this a little bit in this little article. What you're trying to do here is you're trying to reduce the size of your model by manually meshing some surface geometries. You want to check the number of polygons in your mesh geometries with something called the what command in Rhino. So if you had, like, for example, like a sphere or a box or something inside of Rhino, you could type what. Actually, it needs to be a mesh, but if it's a mesh, you could type what in, and you'll be able to get like the number of polygons. And you want to keep that probably below 500,000 polygons is what we recommend. You want to make sure you don't have gigantic texture files. So if you have like a texture applied to a geometry and it's like a huge image size that can create an issue. And then the last thing you want to do in terms of the optimization is check if you've got any block instances. So people use blocks, especially if they're going between Revit and Rhino. Currently, Fologram doesn't support block instances, certainly on our roadmap in the future to do so, but currently we don't support them. So just be aware if you've got any block instances to explode them. The other things that you want to do is you want to organize all of your layers based on your presentation needs. So don't have your layers as like, you know, option 1, final option 2, final option 20, and then just like all these kind of like different things going on that you can't easily navigate inside of the Fologram app. And the other thing I'd highly recommend doing is just create a separate Rhino file for your AR presentation. So your AR presentation is obviously its own thing. You're trying to, you know, show something through that application. Try and keep it separate from your design model when you're going into Rhino. So I'm not going to give a Rhino explanation in this workshop. I'm just going to assume that everyone has at least a basic Rhino explanation. What we're going to do is we're going to open up the Barcelona Pavilion example file that I was talking about. So if I bring up our community forum and you go to the Digital Futures 2020 and jump over to aligning models to physical space in Fologram, just make sure you've downloaded this Barcelona Pavilion 3DM file and the QR origin code. If you had a printer, you could quickly print this one off, but you don't need to for this. I'll demonstrate that. It'd be great if you could print it off after the workshop and do a few kind of origin alignment tests, but I'll talk through how we'll go about doing that in more detail in a second. So just go ahead and download that Barcelona Pavilion file, and then in Rhino I'm going to go File, Open. I'm not going to save changes to that file I've got there, and I am going to go here and download this Barcelona Pavilion file just like that. So you'll just get a little Barcelona Pavilion model on your Rhino screen. So I'll give everyone a minute just to get that up, just in case you haven't downloaded it from the forum. So just get that up on your screen, and we're going to try and send this geometry to our mobile device in Fologram. So one thing I hope you've remembered to do as well, I'll just give everyone like one last kind of little warning about it, is make sure you've got the Fologram for Rhino plugin installed on your machine as well. So you can download it from our website. So if you go to fologram.com and you go to downloads, you can get a free download of the Fologram for Rhino and Grasshopper plugin. So you will need that to connect to the device. So if you haven't done that already, please quickly go ahead and do that. I'm going to demonstrate how it's going to work, how you bring up the plugin. So potentially on startup, you'll have a situation where you don't see anything straight away with Fologram. So you might not be 100% sure if it's installed. The easiest way to check is to just go into the command line and type in Fologram. And basically that'll bring up a little panel, the Fologram panel, that's going to allow you to connect to your Fologram device, basically. So I'm going to go and dock that over here with the layers and whatnot. So we've just got like this little kind of like extra tab up here. Now the Fologram application itself has 3 little tabs. Just focus on the Connect tab for now. I'm not going to get into too much detail about the other 2 tabs. If someone needs a troubleshooting problem, we might talk through them later on, but we're just going to look at this, initial connection to begin with. So let's go ahead and we're going to try and connect a device. Oops, my phone's just gone to sleep mode. Give me 1 second. We're going to go ahead and try and connect a device to Fologram. So I'll just get my phone back up, sorry. There we go. And what I might do is I might actually just do a hard reset of Fologram. So I'm actually going to close the app like that, and I'll close my Wi-Fi one just there. So then I'm going to go over to the Fologram application, and you're going to see that we're prompted once again with the scan a QR code to connect, or load a model with the button below. So what we're going to do in this instance, we're not going to use the load a button, we're going to use the load a model option. We're instead going to scan a QR code to connect. So to bring up a QR code on startup, basically what you do is you come up to the Fologram tab in Rhino and just click on connect a device, and what will happen is a large QR code will appear on your screen. And what this QR code is going to enable you to do is it's going to enable you to create a connection over your local Wi-Fi network to your mobile device. So I'm just going to pick up my mobile device, and we go ahead and try and scan this QR code like that. And if I'm on the same Wi-Fi network, I shouldn't get an issue with connection. It should just automatically go and connect for me, and I should be able to go and place this model, once again moving around the screen. I should be able to go and place this model somewhere on my desk or something, just like that. And you'll see that straight away mine comes in really, really large on my screen. So you can kind of see I've got this at 1:1 on my device. Previously we had the Via Savoy at 1:50. So what we want to do perhaps straight away is go ahead and maybe just scale this down. The other thing just you want to check as well, you'll get a little connection hint over here on the right. This is going to list out all of the devices that are connected to your Rhino session. So right now I see that my phone's connected. You should get a little indication of whether or not your device is connected. And it'll tell you if it's an Android, it'll tell you if it's a HoloLens. And what's really great about this is that multiple people could connect to the same local session at once. So if you were in like a classroom environment, or you had like a client that you were trying to show your model to, you could easily go and connect the same session and view the same live model all at the same time. So it all works kind of the same. I'm going to go and open up the edit menu, and we'll get that square grid that will appear on the screen. And I'm going to pinch inwards and try and scale that model in. I'm going to try and maybe make it like a 1:100 or something. Oh, 1:50 is pretty good actually. Let's maybe go with a 1:50. So I've just gone and scaled my model down nicely at 1:50 there. So go ahead, open the edit menu once you've made that live connection, and you should be able to scale your model down to 1:50 on your device. So one thing I will touch on as well, just really quickly, if I go and like move something like we were doing previously, say I move that roof on top of the screen, in this case I can just go over to Rhino and I could go undo, and then undo that. So obviously whilst you can't undo a command inside of the Fologram application itself, you can easily undo a command in Rhino if you accidentally do something. So we're creating like a live connection between these two things. So the other thing that obviously buys into this live connection, other than the moving around, we could open our layers menu now. And I might bring my layers menu up on my Rhino session as well. If I go inside of my Fologram device, I could turn off the walls of this model. You'll see that updates in Rhino as I update it on my device as well. So that live link not only works with that geometry, it also works with the layers itself. And one thing I want to just quickly touch on right now, just for everyone's benefit, is I want to quickly talk about what is synchronized and what is not synchronized when you create that live connection. So obviously what's happened here is we've sent all this geometry to our mobile device, and we've got all of the layers appearing in our menu. But what you might notice if you've looked through all the layers is there's one layer that isn't appearing in our device. and that is this granite walls, I think it is, layer. I'll just expand that out. This granite walls layer here. So if you look through your layers inside of Fologram, granite walls only appears when you turn it on. Okay, so just be aware that upon connection, sometimes upon connection, if you don't have a layer turned on, the geometry won't be sent to the device. So I highly recommend you kind of just turn the layers on in your whole model that you want to see, and then turn them off after your connection. So just be aware that that geometry isn't sent straight to your device until the layer itself is turned on. The reason for that is that you can have these issues where if you have, lots of geometry sitting on a turned off layer and you quickly want to make a connection between your live model and your device, you don't want to basically crash the device by sending all this background geometry that's on an offline layer. So maybe if you want to have a quick experiment with maybe moving around those geometries and watching how that updates live in Rhino. So obviously if I go and rotate or move a piece of geometry, it's going to go ahead and update in my Rhino model. Just have a little bit of an experiment turning the layers on and off and get a feel for how that live connection kind of works between your device, your mobile device, and the live model inside of Rhino. Okay, so if you're having an issue with the connection, I think Will's in the background, he should be able to problem solve a couple of them. I'm just going to quickly talk about one last thing in this little session, and then we're going to start quickly looking at how we could move into Grasshopper, but we might have a quick 5-minute break before that just so we can work through a few issues that people might be having. I'm going to say, for example, if you've gone and placed your model and you want to align it perfectly on your bench, or on your desk, as I was talking about previously, what we talked about doing was going to the edit menu and maybe kind of like moving it and then rotating it around in physical space like that. But this is not an accurate way of doing it, and it's also really annoying. So to go ahead and align my model to physical space is a pretty manual and inaccurate task. So what we can actually use in Fologram is we can actually use something called a placement QR marker. So this is one of those extra items that I was kind of saying it'd be great if you could download from the forum. I'll talk about generating a QR code, I think, in another tutorial if we have time, but basically you can download this one from our website, and this is just an origin marker. So you can easily go ahead and just download this one from the forum and print it off. So if you print this off, basically you can scan it with your device to align your model into physical space. So you can kind of see here, I've got my QR code printed off nicely for me. You want to print it off with no scaling, so I've printed off an A4 QR code marker, and I'm just going to go put it on the edge of my desk here. So if I go ahead and move my model, maybe I'll go put it on the ground for now. You can clearly see that my placement QR code is just sitting there. So what I'm going to do is I'm going to go ahead and I'm going to go to the bottom right of my screen where I've got these 4 squares in the edit menu, and within the menu, within the edit menu, we have like the QR code snap option. So you see a little QR code appearing there on your device. I'm going to click on that, and it's going to ask me to look at a QR to snap. So I'm just going to go and hover over the top of that, and my model will nicely align to that QR code marker. So my origin of this model is kind of like in the middle of the Barcelona pavilion. So that's kind of aligning it nicely. So then if I went and snapped it again, I could easily go and snap that, and that'll straight away align to the physical space. So what I highly recommend you guys doing this evening after the workshop is printing off that QR code marker and having a quick play around with aligning models to physical space. So that's the origin QR code marker. So as I said before, it creates a model of the origin. If we found the origin point of the Barcelona Pavilion, it's just sitting over here at the moment, just in there in the middle of it. You might want to go and align the whole model itself to 0 as well, and then you'll get actually a bit more of an more obvious alignment. So you'll see now that it's aligning perfectly to my QR code marker. So if I went and move that onto the ground, there's my QR code marker. I can go and easily snap that. Easily snap that onto my my QR code marker just like that. And that's the easiest way to go ahead and align your AR model to physical space. So one last thing, just because there was a question about it, I might just quickly talk through. You can create your own custom QR code markers quite easily. So say for example, if you didn't want to have just a QR code at the origin, you could easily go in and type Fologram QR, which is a command in Rhino if you've got the plugin, and then basically create a plane, and a QR code marker will kind of appear at that location, and then we could give that marker, a name. I'll just call it test marker. And then that'll create a test marker on your desktop. So once again, just if you missed it, all I did there is I just typed in Fologram QR, which is a command here if you've got that installed nicely on your machine. Fologram QR, click on that, and you're able to kind of create a little plane, set an x-axis direction, set a y-axis direction, and then give it a name. I'll just call it test2, and that'll go ahead and create that marker on your desktop. But generally speaking, for much more simpler things and most tasks, a QR code origin marker is easily enough that you'll need to work with. Basically, unless you're doing a really large-scale fabrication task where you need to align to different locations in a larger space and you need high levels of accuracy over long distances, you wouldn't need anything but the origin marker until those situations kind of came up. Cool, so we might have a quick 5-minute break, so you can all have a quick play around with, connecting your device to your Rhino model and streaming some geometry through. And then we'll reconvene in 5 minutes and we'll start taking a look at some of the Grasshopper tools that are embedded with Fologram, and we'll start looking at how we can start creating our own kind of event-based mixed reality applications within Fologram on our mobile devices. Also, if you're having any issues, just chuck them in the chat and we'll try and resolve them as we go through the webinar. Of course, if it's a larger issue, we'll try and resolve it on the community forum so everyone can see, and then the chat doesn't get flooded with hugely technical things. Because I think we're restricted to 200 characters in the chat itself, so it is a bit hard to resolve every single issue in there. Hi Renato, so I just saw your question in the chat. So when you say it's rotated, I assume what you mean is that it's rotating the model. So for example, I'm going to go ahead and snap this model to this QR code, and it'll rotate your model to the alignment of that QR code. So obviously with a QR code, if I were to get one up on my screen, there's a y-axis and an x-axis, and it's going to align your model to that plane itself. So it won't just like move it to an origin point, it actually aligns it in 3D space to these axes in the QR code. Hi Jude, I just saw your comment in the chat. Just to clarify, so you're saying that the Via Savoy model is showing with the Barcelona Pavilion model? If that's the case, I mean, that sounds like a strange bug if that's the case. Maybe just restart the application. So like if you watch my screen, I could just go and hard restart the Fologram application and reopen it and just see if that fixes your issue. Let me know if that is the problem as well, because it sounds like a little bit of a strange bug. Then of course you can just easily reconnect and go ahead and replace your model somewhere. So I'll just answer a couple of those questions in the chat. So the Barcelona Pavilion model, as I've kind of mentioned, it's on the community forum. So just go ahead and download it from the Digital Futures board on our forum. If you go to Digital Futures here, we've got a little aligning models to physical space with the Barcelona Pavilion.3dm. So as I mentioned before, you can grab the model there. What was the other question we had? When can you change the render options? So no, like I'm guessing what you're asking in that situation, Meet, is like, can you go to rendered mode or shaded or wireframe? No, you can't change the render mode inside of the device application. All right, what we might do is we might just start moving forward. what I think we're going to do now is we're going to just jump into some Grasshopper stuff. It'd be good to get a feel in the chat from everyone what your Grasshopper skill levels are. Like, just type in what your experience level is. Have you never used Grasshopper before? Are you a Grasshopper newbie? Like, have you started using it but you're very kind of like in beginner mode? Are you an intermediate user, like you use it at school and in certain projects? Do you use it all the time, like in your day-to-day business? Or are you an expert and you write your own Grasshopper plugins? I'd love to hear from everyone as to what their experience is with Grasshopper, just so we get a feel for where everyone is and the kind of pace that you guys want me to go with. So I mean, I'd say my Grasshopper experience is probably very high. I use it every day. I don't publish any plugins I write, so I wouldn't say I'm an expert, but I'd say I'm a very high experience in Grasshopper. So I'd love to hear in the chat where you guys sit from an experience level. So we've got an intermediate level, that's great. Anyone else want to jump in the chat? We've got a couple of beginners as well, that's totally fine. We're not going to do any game-changing Grasshopper data tree stuff today. We're going to primarily look at Fologram tools. So if you haven't used it before, you're a beginner, don't worry. We're not going to, do anything crazy today. But it'll basically enable you to it'll just show you how easy it is to create an application inside of Grasshopper. So it seems everyone, yep, cool, lots of intermediates. It seems everyone's about newbie to intermediate, generally speaking. In the chat window, which seems like a good group for what we're going to start looking at. I think there'll be lots of benefits for everyone. Okay, except for Iana, who uses it almost every week. Great. Cool, so anyway, if you haven't used it or heard of it before, Grasshopper is an algorithmic plugin for Rhino that gives us parametric control over a series of relationships that we're able to create through node-based components. So that's kind of jargony. Essentially what it means is that we can create infinite design options through a series of relationships that we design and control inside of Grasshopper. And we can extend this control directly into our Fologram session. So I'm going to go ahead and open Grasshopper. You can do this by either clicking on this little launch Grasshopper icon, which is the little green bug in Rhino, or you can just go into the command line if you can't find that green bug anywhere, and you can just type in Grasshopper like that, and we could go ahead and open Grasshopper up. And one other thing that I'm going to do, I'm going to go up to where my Barcelona pavilion is, and I'm going to go File, New. So I want everyone to go and do this as well. So please go ahead and go File, New. I don't want to save changes to the Barcelona pavilion file. And I'm going to go ahead and open a large objects meters file in this instance. So kind of please copy me here, go large objects meters. I'm going to go ahead and open, and we're just going to have a new file. What you'll notice in Fologram is you'll still be connected to that same session despite going File, New. So just go ahead, like I said, get rid of the Barcelona pavilion, go File, New, and large objects meters, sorry. We want to open in meters. So Grasshopper is going to appear. It's going to look something like that. Once you've got the window open, I'm just going to go and File, New. You'll get a window that looks like mine. If you haven't used it before, don't do this and have it full screen covering your Rhino session. What you want to try and do is either use it across two screens or just have them on the same screen parallel, so you can kind of see what's going on in Grasshopper and how that's affecting your Rhino file and vice versa. So you want to use both of them in tandem rather than having like Grasshopper full screen all the time. So just go ahead and resize that window. So the interface itself is pretty simple. At the top, you've just got a typical file menu. And then beneath that, we've got a series of tabs which contain things called components. So components are the basis of Grasshopper, and they essentially serve as commands that give us parametric control over a whole number of tools in Rhino. You might have like a number of different tabs compared to mine. So I've got a lot. Some people have way more than me. Some people have way less. Don't worry if yours looks a bit different to mine. That's just because I might have some different customized plugins installed and you might have some different ones installed as well. And that's totally fine. The only extra plugin that you need for today's webinar is Fologram. So if you've been using Fologram already, you should have the Fologram tab with a bunch of custom Grasshopper tools that we can use in Fologram. So today we're just going to talk through a few of the more simple components inside of the Fologram Grasshopper workflow. And in the coming days over the course of the workshop, we'll explore pretty much most of these components a little bit more thoroughly across a few different projects through the lens of fabrication. So then obviously below all of these, components as we're calling, where the plugins sit. You've got a little menu here. This is kind of like a visibility menu with a few extra different tools. Don't worry about that too much for now. The main thing that you want to worry about is this big blank space down here. This is what we call the canvas, and this is where we'll drop our Grasshopper components on to create our parametric relationships that I was talking about before. So the navigation is pretty similar to Rhino. So, if I was in Rhino, zooming out with the scroll key, you can rotate around with the right mouse. Zoom in, zoom out's the same. If you use the right mouse, you can pan, basically. It's almost like a 2D Rhino view inside of Grasshopper. So pretty simple stuff. So what we'll do first is let's create our first Grasshopper component for those of you who have never used it before. So we're going to start pretty simple. I'm going to go ahead and just create a sphere. So I'm going to double click on the canvas and I'm going to type in sphere. Like that. And straight away a few things are going to happen. So basically what I'm doing here is I'm double clicking on the canvas and I'm just searching for a sphere. By typing in sphere. So it's kind of like, typing into the Rhino command line up here. You could also pick a sphere from surface and then primitive, and then there's a sphere component just sitting there. They're the same component, but that double click just enables me to search for that so I can, access that component a lot more quickly. So once I've selected that sphere, you'll see the component itself will appear on the canvas, and it's kind of like this little battery looking thing, kind of labeled sphere. So this battery looking thing has a couple of inputs and one output, and these inputs actually dictate the properties of the sphere that we're creating, and then they spit out a geometry that produces the sphere. We've also got a bit of a change in Rhino. In Rhino you can see we've got a red kind of translucent shaded preview of a sphere. I can't actually select this in Rhino or do anything with it. So it's important to know that this is a preview in Grasshopper. This is not something that we can, go and move around in Rhino easily. It's basically a preview of the geometry that we've created inside of Grasshopper right now. You'll also notice I've still got my device connected to this session. So I've got Sean's iPhone connected over here. And no sphere has actually appeared just yet. And I'll talk through why that is shortly. Basically, what we're going to do with this sphere is we're going to just affect some of the inputs of it. So we're going to affect its size, we're going to affect maybe its location as well. So currently, the sphere is located on the XY plane in our Rhino session. So if I hover over this base input, basically the base is basically telling Grasshopper, hey, locate the sphere at this location. So the base location is the world XY plane, which is just here at 0, 0, 0 inside of Rhino. We've also got instructions for a sphere radius. Now remember, we're working in meters right now. So currently this sphere radius is actually quite big. This would be a pretty large sphere that we would get if we were to go into our Fologram session. So maybe what we'll do first is we're going to try and affect this radius with something called a number slider in Grasshopper. And number sliders just give us parametric control over our design relationships. So we can create a number slider by double clicking on the canvas and typing in a number. So I'm going to type in a number 0.50. So that's going to be half a meter in the units that we're using. And I'm going to hit enter or return, and a number slider is going to appear on my canvas. And what I'm able to do with this number slider is I'm actually able to click and drag on it with my left mouse button to easily change the value inside of Grasshopper like that. So I'll just repeat that again if it's your first time using Grasshopper. Just double click on the canvas and type in 0.50 and you should be able to create a number slider like that. So what we can actually do is we can create a parametric relationship between this number slider here and this sphere over here on the right. You'll notice that there's a little node coming out of the number slider output, and when I hover over it, my cursor kind of slightly changes to have a little arrow pointing in the right hand direction. If I click with my left hand mouse button and drag, I can actually pull an arrow out of this slider and create a relationship between this slider and the radius of this sphere. So I'm going to let go, and you'll see that now this number slider controls the radius of the sphere. So I could go and drag that from side to side and easily change the size of the sphere itself. So once again, the units are pretty important for this. I'm working in meters, so that's why I've gone with such a small unit. So just be aware of that for you guys. I'll just give everyone like a second if they're falling behind or they've been dealing with a few connection problems. What we can quickly talk about is the problem I was just discussing before though, and you'll see right over there, I don't actually have a sphere appearing in my, my output. So despite the fact there's clearly a sphere appearing as a preview in Rhino, and I've dropped a sphere onto the canvas in Grasshopper, I don't see that in my Fologram device. Why is this? So if you've used Grasshopper before, you're probably aware that you might have like a much more complicated algorithm than this with lots and lots and lots of different components. And a lot of the time you have lots of different components turned on, you have them turned off, you have heaps of different types of geometry in your file. You don't want all of that to be constantly sent to your device. So the way Fologram works is that we basically prompt the sending of this geometry to our device through some of Fologram's Grasshopper tools. So if we all come to the Fologram tab in Grasshopper, we're going to start looking at a few of the tools that we have inside of Grasshopper that we can use to send geometry and send parameters to our mobile devices. So the tools are kind of organized into 4 drop-down menus. We have the flow menu here, we have the sync menu, the track menu, and then a few utilities. Today we're just going to focus on some of the tools under the sync drop-down menu. As I mentioned before, in some of the upcoming workshop sessions, we're going to look more in depth at pretty much all of these different tools. So I'm going to click on sync, and we're going to basically first look at the sync object component, which is right here. So I just want everyone to click on sync object and just click once on the canvas to drop it there. You could of course double click and type sync object and choose it again. So it's that cube with the arrows pointing around the side of it. So just go ahead and drop that onto the canvas. Straight away I'm going to go ahead and from this output of the sphere I'm going to hover over and get that little output. I'm going to drag into sync object, and you'll see that the sync object appears here nicely, and I do get it appearing in my Fologram session. So one thing you might notice straight away is that it's really small, and there's a reason for this, and you might have done this as well, but my geometry is or my Fologram session is actually still at the scale of like 1 to 100, I think. So you want to go ahead and make that a 1-to-1 scale. And straight away, my sphere is actually trying to downsample. You're probably not going to have this same issue. I think this is a little bug I'm experiencing. I might just restart my Fologram session actually and try and get that one coming up a little bit more nicely. But basically, anything that you plug into the sync object geometry that is say a, oops, that one's not loving it actually. Maybe I'll go with a mesh sphere. I'm just going to quickly change my geometry to a mesh sphere, guys, so it doesn't downsample that geometry. There we go. Like that. So now I've got my sphere appearing in my device, like that. Cool. So any surface geometry, any breps, any curves, any meshes that you plug into this sync object component will appear inside of your Fologram device. So just let me know in the chat if you've been able to send, a sphere to your session. Let me know if you have any issues in the chat. Cool, so I think everything's looking okay. One thing that you would have noticed about this component, and if you're a regular Grasshopper user, you'd be very experienced to know that most components have like a number of output or a number of inputs that you can easily change and customize. So the sync object component's been designed to be super easy to use, so you can just plug your geometry in and have it appear in your session. Without a bunch of messy kind of inputs, but there are a bunch of hidden options and things that we can change really easily in our sync object component. So I'm going to go ahead and go right click on the sync object component, and if you right click on that Fologram logo, you're going to get a series of colors and color pickers. So basically we can easily go and change these colors, change the material color of this sphere. Oh yeah, so a couple of people are having the same issue that I was having, so it might be a little bit of a bug, but basically because the sphere component is a geometry that has, it's a NURBS geometry, it's not a mesh. I think what Fologram's doing in that instance, it doesn't usually do it, but probably just a little bug on a couple of people's sessions, is that it's downsampling that to be like a much low poly geometry. So go ahead and maybe just swap it out to a mesh sphere for now, and you should get the mesh sphere appearing like I do. So as I was saying, there's lots of hidden options in the sync object component, so you can right click on the sync object component, and we could go and change the material, so I could go and change the color of it, and you can see in my device up here, this changes live as I'm going around and changing the material. We could add some gloss or some reflectivity to this material as well if we wanted to, so that it has a bit more of a material properties. You could go and change the color itself. Maybe we'll make it a blue sphere or something like that. Cool, so yeah, just go and swap that out for a mesh sphere right now. I think it's to do with the units we're working in. One thing that I'd just like everyone to quickly do if they haven't already, because we might just quickly talk about this as well whilst we're here. If you're on the Digital Futures forum, on our community forum, and you haven't already, just download the files for the interactive timber bending design. So that means download the fields design template file, and then just right click on this image and save that image out as well. Basically, we're going to go and apply this image as a texture to our sphere. If you're having an issue with your sphere not appearing on the application, just go ahead into the edit menu and check the scale of your model, because you might actually have it a really tiny scale, so it's like, you can't see it. So just make sure that's at 1:1. And then also, of course, just try and replace your model so that you know that your origin's not somewhere off in the distance, and you should have your sphere appear there, like that. So once you've downloaded that texture file, once again, just in case if anyone wasn't looking, download this texture file from the Digital Futures board on the community forum. We could right click on this sync object here, and we could come down to the option that says select texture, and we could go ahead and apply a texture to this sphere geometry. So I'm going to go to select texture, and I'm just going to navigate to where I've saved this timber texture file, which is right here. And I'm just going to select open, and straight away that timber texture is going to appear nicely on my sphere. So everyone just have a quick go at doing that timber texture. If you want to remove the timber texture, you could right click on the sync object and just click on that timber texture again, hit cancel, and you'll be prompted to clear the texture once you close that dialog box. So I could go and clear that texture, and it'll revert back to that, purple sphere that I had before. But once again, just if you missed that first part, I'll just redo that again of the timber texture. Right click on that, go to select texture, and it doesn't have to be the timber texture if you don't want it to. Like, you could put any JPEG or PNG file in theory onto this. But I'm going to go and select timber texture, open it, and that'll just update on my screen and in my device. Cool. So I want everyone to just take a moment to try and move their geometry in the Fologram app on their device. So previously, when we were in the Via Savoy model, we were moving the roof around and some of the walls, and it was getting a bit messy, but it was really easy to do. I want everyone to just try and drag and move their sphere around inside of their device. So I'm going ahead and I'm trying to move and drag mine. And as you're probably experiencing the same thing, I can't quite move or interact with the geometry on my device. It's just kind of sitting there in my application. So by default, any synchronized Grasshopper geometry that we send to our device aren't able to be interacted with. We basically have to prompt our object to do this itself. So it's easy for us to do that. We just right click on the sync object component again, and we want to just come down to, there's two options here. There's a clickable option and a movable option. Now, clickable objects allow us to click on a geometry with our device, and this can be really helpful if we're creating like a custom application that relies on touching an object. Like, say if we want to draw onto a plane or something, we could make it clickable. But in this instance, we want to make it movable because we want to move this geometry around, we want to scale it, we want to rotate it. So I'm going to go ahead and select movable. And now on my device, I should be able to go ahead and move my sphere around. I should be able to scale it and rotate it in AR. And you can easily go and view that in 3D space and move it around at the touch of your fingers. So everyone just have a quick go, make sure that that's working. So just once again, right click on the Fologram logo and make your object movable. So if you're a little bit newer to Grasshopper as well, you'll probably notice on your screen that you have like a little shaded preview of two spheres. So you've got your wooden sphere and then this other sphere. Just be aware that that's just a preview of this component here. So it's showing you where the sphere originally was in this component. And that's why we don't send every component to Fologram by default, because otherwise you'd be seeing two spheres which become annoying and you wouldn't be able to control exactly what you want to see inside of Grasshopper. The other thing that I want to notice I want to mention that you've probably noticed that has changed is we've now got a little bit of a dashed line in between our mesh sphere component and our sync object component. So in Grasshopper, generally when you see a dashed line, it usually indicates that perhaps you've got a data structure or something, and that's a slightly different dashed line to what we're seeing here. This is a different type of dash pattern. What this is telling us is there's a dependent relationship between these two components. So this move transformation in the synchronized object, it depends on whatever's going on back here. So if we go and change something previously, it'll reset that the location and the rotation and the scale that we've applied to that geometry to its original position. So you'll see if I go and move this slider, my geometry snaps back to that middle location. So just be aware of that little kind of dashed line there. If you see that and you change like a parameter previously, you'll lose the transformation data that you've got there. So everyone just test out that little relationship if you've got some issues there. So there's a question about, can you see the shadow of the created object? Obviously, I can't see the shadow because I don't have a plane. If you put a geometry plane down, you could probably see the shadow. But just by default, we don't cast shadows onto tracked surfaces in the Fologram app. The last thing I want to mention with the sync object component is that we can also input curve geometries. So let's go ahead and create a simple polygon component inside of Grasshopper. So I'm going to go to the curve tab in Grasshopper, and under primitive, we've got a polygon component here, but you could also just double click on the canvas as we've done before and type in polygon like that. And I'm going to give the polygon a similar radius to what we've got the sphere as, so it's just sitting there. And I'm actually going to go ahead and send this polygon to the sync object component, overriding the mesh sphere. So if I go and plug that in without holding any buttons down, that'll override that component. And you'll see that I'm able to send that curve geometry to my device. So my hexagonal polygon is now appearing, and I could go and change, that interactively. I could also right click on the sync object and change the preview radius of that curve. So I could make it 10, and we could have like a thicker previewed line. And of course all the material settings are coming through on the curve, funnily enough, so you get that like that timber texture coming through on the curve itself. I'm going to go ahead and plug that mesh sphere back into the sync object component. And I'll just give everyone a quick minute to play, or if you've got any problems, maybe just address them in the chat before we move on. One thing I would like to just quickly say, so this isn't something that's just happening in isolation, so we're actually going to use this relationship that we've created on a more complicated application in about 10 or 15 minutes. So the mesh sphere itself will become a larger part of a perhaps more interesting AR application, and we'll get to that in about 10 minutes or so. So yeah, I'll just give everyone a couple of minutes to have a quick play around. Okay, so we might keep going then. Just earlier I demonstrated how we can kind of break a live link between our moved synchronized geometry and any parameters that are kind of linked before it. Now, when we moved this slider across to demonstrate this, I'm sure you probably found it a little bit annoying like I did, that I had to go back to my PC and move this slider around whilst, I was looking at my device and watching that change in my device. Which is kind of annoying. It's like annoying to having to go and move that slider around in Grasshopper. So luckily for us, Fologram supports remote control from your device through these kind of parameters. All we need to do with this is we just need to synchronize the parameters that we have in Grasshopper with our mobile device. And to do this, we want to create a synchronized parameter component. So I'm going to come back to the Fologram tab, so the Fologram plugin for Grasshopper, and under the sync tab, we've got a sync parameters component, and we're going to drop one of those onto our canvas like that. So the sync parameters component is a bit of a funny one. It's not like your typical Grasshopper component. It doesn't have any inputs and it doesn't have any outputs. It's just a little pendant that kind of sits here, but you'll notice straight away when we drop it onto the canvas that there's a change in this number slider that we've got here. There's a little Fologram logo that's appeared right next to the number slider, and this is going to give us the ability to send the parameter to our device so that we can control it remotely from our mobile device, and we don't need to go into Grasshopper and move the slider around anymore. So to turn it on, I just need to click on that logo, and you'll see straight away it turns purple, which gives you an indication of which sliders are connected. So if I click on this sync parameters component, you also get a little trail that shows you which parameters are actually being synchronized right now. You'll notice that nothing's actually changed in my device right now though. So where on my device can I actually access this number slider? There's one menu that I haven't talked about just yet, which is called the parameters menu. So let's bring up that menu. It's the bottom left menu, which has like the little kind of slider looking icon. So I'm going to click on that, and you'll see straight away that I've got a number slider, which is completely linked to this one here, appearing in that menu. I could turn that on or off, and it'll disappear or reappear from that menu. Go ahead and turn it on, and then try and slide it using the number slider in your device. And you'll see straight away you start to get parametric control over your sphere remotely from your device. So you're able to control some of the parameters in Grasshopper live from your device. You can go slowly up and down as well with number sliders and easily change and move things. So this gives us a lot of power over our Grasshopper definitions when we're trying to use them inside of AR. There are a few other different things that we can synchronize as well, but I think we'll touch on them potentially tomorrow in tomorrow's workshop session. But that's just one number slider that we can easily go through and apply as a parameter for our mesh sphere. So one other thing that I just really quickly want to discuss with this is there's a second feature that's available to premium subscribers only of the mobile device. If I drop a few number sliders or make a copy of this one on my canvas and I start trying to synchronize them, so I could synchronize that one and I get a second on my device, I could synchronize that one and I get a third. The moment that I synchronize a fourth slider, I get a little message that tells me that this synchronization feature is limited to 3 parameters in the free version. So if you want to synchronize more than 3 sliders, you'd need to upgrade to the premium version of the Fologram app. For this workshop, we probably won't ever need to go more than 3 because I'm trying to design the examples so that it's easy for you all to use. So don't worry about the premium upgrade if you don't think you need it right now, but just be aware that you can't synchronize more than 3 parameters with the free version. But it's really great, so we get that kind of control, and you'll notice the sliders updating live in my device just there. Cool. So that's pretty powerful little tool, an easy one to use as well. So just dropping that sync parameters pendant, which can be found in the sync here, enables you to make all of those parameters transferable to your Fologram device. So that kind of leads us to the last little bit of what I want to cover in today's workshop, which is I want to go ahead and apply all of these little tools and ideas that we've learned, really simple things in Grasshopper and Rhino, and apply them to a perhaps more interesting, more complex Grasshopper algorithm. So what I'd like you to do is I'd like you to go to File, Open Document in Grasshopper, and I want you to open this field design template file that was on the community forum. So once again, if you haven't downloaded it already, it's under Interactive Timber Bending Design. Just go to field design template file and download that guy and get it open in Grasshopper. So I'll just give everyone a minute to go ahead and open that one in Grasshopper. And you should just you should start with a little kind of swirly field aggregation that'll be appearing in your Grasshopper window. Sado, I mean, I just saw your comment in the chat. What more information would you like to hear about the sync parameters? Are you looking for like a technical description as to what's going in the background, or just more generally speaking? Once everyone's got this up, by the way, I think we'll keep pushing on because we're pretty close to the end of today's little workshop. And then I just want to talk about, a little task that you can go and complete in your own time based on what we've learned today. So like kind of a lead into what the task will be is we're going to use this fields algorithm to create our own kind of little timber strip aggregations inside of AR, so inside of the Fologram app. But we're going to make them interactive so you have a little bit of design control over them. So basically what this algorithm is doing, if you've used the fields components in Grasshopper before, you'd be a little bit familiar with them. But basically, we're running a very simple field simulation with some spin forces and some point charges. And what that does is it basically creates a field of vectors where we specify some starting points, and each of those starting points step through those vectors, and they basically create these long kind of curves. And then over here in the definition, I'm just writing a little kind of timber strip behavioral algorithm, very simple, not really totally optimized for fabrication, but just gives you an idea of what your timber strips might look like so that we can kind of preview them. And I've gone and highlighted all of these groups with a few colors. So the purple groups that you see are the groups that we're going to go and change and affect in this simulation. And the white ones are the things that, just for right now, you can leave them alone, but in your own time after this workshop, you could go and have an experiment around. So you could go and, do your own custom field simulation or change things, change like different parts of like the simulation that's kind of generating it. So basically what's generating the fields right now is a curve. So you can kind of see this green curve. I'll just toggle on and off There's this curve in here that's kind of generating where those fields are running. The other thing that's kind of dictating where these fields are these two planes. So these planes are actually the basis for what we call the spin force in our field simulation, and they're creating kind of like this swirling geometry here. So if you're new to Grasshopper, you don't really need to worry about this, because we're just going to give you the tools to easily move and manipulate these things around yourself. So you don't necessarily need to understand exactly what's going on the definition to have your own design implementation or imprint on this. So what we're going to do first is we're going to create an interactive curve geometry that we can easily go and manipulate and follow. In fact, actually, maybe what we'll do first is we'll just send this geometry to our Fologram session. So I'm going to come to the end of the definition over here. So I'll zoom out again and give everyone an idea. So this is our definition. I'm going to come to the far right over here, and I'm going to zoom right in where it says mesh. And these are just the output strips that we've got coming through over here. I'm going to use a sync object component to send these geometries to my device, just like that. And hopefully they appear. Yep, they're pretty big. You can kind of see them in my physical space. I might actually scale this one down actually to maybe like a 1 to 20 scale or something, or 1 to 10 seems to be pretty good. Maybe we'll go 1 to 20 actually. So just go to the edit menu and scale that down, and you should be able to get, you know, some fields appearing like that once you've sent that geometry with a sync object component. I'm going to do exactly what we did before and right click and just go and select a texture, and I'm going to apply that timber texture that we were using before so that we start to get, you know, a timber textured coming through in our device itself, just like that. So now we've got, you know, these swirls, these kind of timber aggregations, kind of like a steampunk sketch if we were to think of it in a way, coming through with our simple sync object component. Don't make these movable, just leave them as unchecked right now, so just leave the settings as is other than the texture as well. Cool, so I'm going to zoom out again, and what we might do now is we might come over here to this curve geometry. So I'm going to actually pull this over a little bit and give myself a little bit of space. And we're basically going to create an interactive or manipulatable curve using the logic that we formed previously with our spheres. So I'm going to basically, with this curve, I'm going to double click on my Grasshopper canvas, and I'm going to type in control points. And this will give me the control points of any curve, basically. If I plug a curve in, I'm able to get the locations of all of its control points. So I'm just going to click on that and drop that onto the canvas, so we've got a nice control points component there. And I'm going to plug the curve into that. So straight away you'll see a bunch of little points that will appear in Grasshopper inside of our kind of swirling geometry. And we're going to basically try and manipulate those control points. So we're going to move them around as mesh spheres. So I'm going to go ahead and create a mesh sphere, just like we did previously. And that mesh sphere is huge. Basically, I want it to be a bit smaller than that so we can easily control the geometry. So I'll create a number slider as well. I might make it 0.3 as a radius. That's a bit better. And then I'm going to plug my points into base, just like that. And now you'll see that we get all of these points inside of, as Grasshopper previews coming through, and they're just kind of like floating around. And what we're going to do is we're going to make these points, or these spheres, now that we've created them, we're going to make them interactive, okay? So we're going to be able to easily go and move these geometries around, which will actually in turn update the curve itself. Cool, so I'm going to go a little bit slow with this so no one falls too far behind. So we've got the control points component. I think that can be found under curve and just analysis. Yep, it's right there, control points. And then we've got the mesh sphere component. You can find that under mesh primitive mesh sphere. But also if you aren't sure what the component is, just type in whatever's coming up on my canvas and you should be able to get the same control points component, just like that. Cool. So now what we're going to do is we're going to go to the Fologram tab and we're going to go to Sync Object. And I'm going to drop a Sync Object component onto my canvas. And I'm going to plug my mesh spheres into that. So you'll see in my device now, these mesh spheres appear. So I can see them all around in my device. I might make them a nice red color, just so they're really obvious for me. And then the other thing I want to do is just right click and make all of those movable. So go ahead and click on movable, like that. Then I just want to create a mesh container, and there's a reason for that. There's a component we need to use that has a little bit of a bug with it. So I just want to go and create a mesh container just to clarify that that's coming out as a mesh. So you'll see I've got 7 meshes coming out into that one, which are my 7 mesh spheres that I've created that are going to serve as our kind of control point spheres. I'm going to find the area of the meshes just with an area component. You could also use the mesh area component if you have that as well, but the area component will do just fine. So just type in area and select that component like that. And what that'll do is it'll give us the center point of each one of these meshes. So basically it's once again creating like a point inside of here at those locations. But what's important is it's not these original points, it's going to be the ones that we've moved already. Then I could go ahead and just create a NURBS curve like that. So just type in NURBS curve, and it's just that one that looks like a C, NURBS curve. I think it's pretty high up in primitive from memory. I think it's spline. So there it is, NURBS curve there. And I want you to plug the centroid output from area into the NURBS curve vertices here. And then I'm going to plug all these NURBS curves into the mesh pipe. So we're going to override this polylines thing here like that. And nothing will change immediately. You'll get a very slight change because the curve's a little bit different. But you'll still get a very similar kind of aggregation. So I'll make that a little bit more obvious on my screen so everyone can just make sure they've got that correct. So it all looks the same. So plug that into polylines. Now on my device, I could go and start interacting with these spheres. So I could go and move this sphere up. And my aggregation will update. So now we can interactively go and change the field's aggregation with these spheres. So you're able to go and customize your own design based on these sphere locations. If you want to make your definition a little bit faster, you could come over to the field line and change this to a lower value as well. Because basically it's, got to run through all this stuff over here and through here to calculate the whole output. But basically you're able to go and update that design really easily, like that. One thing I just realized actually that people might have a slight issue with, if you don't have Weaverbird, the Weaverbird plugin for Rhino, you might have a gap over here. Just go from that mesh to the sync object component and you should get a similar output if you are having that issue. So that's one way we can easily go and customize our, field simulation. The other way that we can easily customize it is with these surfaces that we've created. So I'm going to come down here to the surface from planes, and I'll just give everyone space they can see that as well. And we're going to give ourselves a little bit of customizability over these surfaces. So I'm once again going to go to the Fologram tab. I'm going to go to the sync object component and drop one of those onto the canvas. I'm going to plug the surfaces into there, and they should appear on my device. So you can kind of see those planes, they're appearing there. I'm going to go and make them maybe a blue color, just so that they're easily distinguished. And I'm going to plug that sync object into here, into the surface, to override that surface there. And now I could go and interact with these planes. Oh, sorry, one thing I need to do, just forgot. Right click on the sync object and make it movable, as we were doing before. I could go and interact with these planes, and that'll update where those kind of spin forces locate. And that'll give us more control over how we go about doing this aggregation. So you can easily go and, change the location of these spin forces. You can rotate them so that they spin in different scenarios. And then you can create your own timber aggregations inside of AR. So suddenly you've got two kind of more customizable options within your definition. And I'll save this final one and upload it for you guys on the forum tonight, just in case you had any issues. Or if you have any issues, just write a post as well, and we're happy to kind of get in touch and help out. So basically now we've got a totally interactive fields definition just using a simple sync object component. Of course, we could start, synchronizing some of the parameters. We could go and drop a sync parameters component onto the canvas, and then we could send some of these things to our definition. So what would be a good parameter to send to our definition? This number slider here, I'm just going to right click on it and call it a radius, which is the radius of the mesh pipe. If you change that, like if I were to change that inside of a Grasshopper, you'll get like a updatable thing. So you can send that parameter to your device and change that. And then basically that'll affect your algorithm as well. So that obviously makes it way more sparse, probably way too sparse. You can make it a lot smaller. And then that makes it a little bit more of like almost like a tube simulation of those. So have a play around with this definition. Basically what I think would be great on your own time over the next 24 hours before we meet again tomorrow, it'd be really great if everyone could experiment just with moving some of these planes around in physical space. So what I mean by that is I'd like you to print off the Fologram QR code marker and just place it somewhere in your apartment or your bedroom or something, and then go ahead and snap to that marker. So hopefully mine works. Well, it doesn't want to work right now. There we go. And then what would be good is if you could try and maybe align the curve to a piece of geometry, say in your bedroom or in your kitchen or something, and start to try and design this field aggregation based on your physical surroundings. And then once you've done that, it'd be great for you to just quickly capture a nice video of your aggregation and maybe just chuck it up on Instagram with an @Fologram, because I'd love to see all of them kind of curated in the morning if you could go ahead and do that. So I think it would be really great. So as the small tasks, have an experiment with the kind of base settings, just moving some of these spheres around. Have an experiment moving some of the planes around. You could experiment and add more curves into this geometry as well, potentially, or change the type of curve you have. You could probably add more planes in as well. You could go ahead and change some of the spin forces. So if you go to the vector tab, there's different fields forces that you can actually apply to these things. And then, like I said, align it to something in your house and try and maybe trace or move the spheres around to a geometry that you find so it contextualizes your design within 3D space. Cool. So if anyone has any quick questions on the live stream chat, just let me know now, because otherwise I think we'll wrap up today's session and we'll say goodbye until tomorrow. But like I said before, it'd be really great if you could chuck some videos up on Instagram so myself and Gwil can have a look through them. In terms of tomorrow's workshop, I will, probably a few hours before the workshop, I'm going to upload a few new example files on the forum, and I'll email you all about them, because tomorrow we're going to look at fabrication sequencing. So I'll run the first session just looking at fabrication sequencing with everyone, and then Gwil's going to run the second session where he's going to talk through designing kind of like a virtual exhibition of some of the algorithms and work that you guys have created in the workshop so far. So I mean, Gwil's answered that, but yes, we will make this session available on YouTube, so you can go ahead and re-watch it in your own time if you like. Cool, so I'll just hang on for a couple more questions to see if anyone has any more specific questions about what we've done today. Otherwise, like I said, same time tomorrow, so I think it's 4 a.m. GMT or something. I mean, it's 2 p.m. Melbourne, Australia time, just to give you guys clarification on our schedules as well. Cool. All right. Thanks, everyone. We really appreciate you all jumping on today. If you have any questions, chuck them onto the community forum and we'll get back to you straight away. Otherwise, we're really excited to see how you guys go experimenting with the Grasshopper algorithm. And I'll send you guys a link to the YouTube recording once it's up on YouTube as well. Cool. Thanks, everyone, for a great session. We'll see you all tomorrow.